minimalise that, throw that down here.
Oh, Elmo's dancing.
Oh, and we're going live.
I think we are live, folks. Good evening, ladies and germs. Okay, no germs.
No germs.
No germs.
Make me laugh now, please. Hee.
Yeah, insert laugh track here. No laugh track? Oh, we're off to a flying start already.
I haven't got a laugh track.
Oh, okay.
There we
got
go.
A laugh track. Okay.
There we go. We're live.
We're live. Yeah, I see
We're officially live. All right.
Don't panic! Don't panic!
Yeah, okay.
I won't.
No, we won't. We're all calm, cool, and something.
We're all cool, calm, and part of the collective.
Resistance is futile.
That's a measurement.
Oh, sorry.
Resistance is futile. You must comply.
Speaking of complying, I thought we might start off with a little bit of those lights in the sky type things that seem to move around at night time.
Some luminaries.
Somebody took a capture of it with their magic box thing.
Oh, but not a P900.
No.
Afraid it's not a P900.
Yay!
I think it's even better than a P1000, but others may disagree.
They can't disagree if they don't know what it is, Alan.
It's a Canon EOS 50D. There are newer and better versions, but hey.
Well, we'll start this off and we'll see what it speaks for itself.
I see. You're going to play it mute. You're going to play it muted, so you don't get to hear my lovely choice of music for it.
No, it's not going to be muted. Here we go.
Oh, that's brilliant.
600 times actual speed.
Are they satellites we see occasionally flicking across the screen, Alan?
Yes, they are. And look, you can see the Big Dipper in that one at the end.
Uh-oh, clouds.
The big fat ones are aeroplanes. The small thin ones are
Satellites. Yeah.
So I think those are aircraft because that one was my first attempt and the exposure wasn't very good. So it's all a bit...
Alan, do you know you are your worst critic?
I know.
You've done a fabulous job with these pictures. It's brilliant.
It's phenomenal.
It's stellar.
I'll say this string was the first one I ever tried, so
plane. Another
Plane,
plane.
yeah, that was a plane.
You've been called out, Alan.
Yeah, I missed in this one. Polaris will be somewhere off the top of the screen.
You want me to scroll down?
Hey. At least I used a real proper magnetic compass to make sure the camera was actually pointing fairly close to due north.
Yeah, and Dinky Die, if you're looking for Polaris, you probably need to go about 30 degrees north from where he's looking.
Yeah, I'm not high enough. I'm too low to the horizon.
Yeah.
But there you go, lovely view of the Big Dipper at the end there. And this one has got Polaris in it. And the big fat ones are definitely aeroplanes, and the thin streaks, I'm pretty sure, are satellites.
So that's Polaris, the top centre there, Alan.
Polaris top centre, and again you can see the Big Dipper swinging round in the bottom left corner.
Pointing towards Polaris.
Pointing towards Polaris. Because that's how we find Polaris. You gotta know which way's north.
Yeah.
And of course, it's 52.5 degrees above the horizon here.
I think it's below our horizon.
Yeah, it is below your horizon. You guys, unless you guys have ever come to the Northern Hemisphere, this is something you will have never seen in real life, isn't it?
Yeah.
No, ever.
Never, ever. Or is it because we can't see that far?
Well, this is supposed to be the centre, so you are supposed to be able to see it, aren't you?
Yeah.
Wow, what's all those dots?
Yeah, that's why I said the exposure in the first one wasn't so good.
Yeah.
I've never seen that many dots in the sky.
Because the first time I forgot and left it on ISO 100, and the second time I remembered and switched it to ISO 3200.
I look up at night here and I can nearly count all the stars I see on one hand.
Well, you can see a heck of a lot. You can see a heck of a lot more stars in this video than you can in with the naked eye.
Yeah.
Being able to integrate the starlight over 8 seconds really helps.
Like the sunny sky.
Of course, there's a little bit of cloud, but that just, I think, helps add to
The reality of it, what do we call it? Realistic.
the reality. Yeah.
Well, it would have been a bit hard to CGI in those clouds, I tell you. Oh, is that it? Oh no.
That's it, I'm afraid. I have to say it does. I think it looks a little better when you run it in when you can run it in the full 4K 60 frames per second glory.
Who is Mr. P?
You can run it in the full 4K 60 frames per second glory.
Who is Mr. P?
You can run it in the full 60 frames per second glory. Have we fixed the audio yet?
Jose Hanger-Honor, eh?
Have a naked person in the chat.
He might not be one of us.
Mr. P.
One of these things is not like the
Well,
others.
I'm sorry. Yeah, okay. The music isn't great, but you know,
Who's
I was in a
complained-
hurry.
who-
I wanted to put
Who
some
complained
audio
about
on
the
it.
music?
Mr. P.
Mr. P.
Mr. P.
I don't know who Mr. P is.
No, we
Mr.
don't
P?
know him, Mr. P.
Well, apparently he's a Jose hangover. So she Kyle with a beard.
Oh, facial hair? Unheard of.
Hey, Alan, next time take Riley's advice. Use a solar filter. You'll see all those stars that you can't see without a solar filter.
Yeah.
Yeah,
Okay.
yeah, sure.
I wasn't going to swear in the first half hour, but what the fuck? How the fuck does he think you can see more stars when you're filtering out fucking light?
When you're filtering out 99.8% of the light that's out there.
You too can make constellations out of dead pixels.
Yeah. Well, that was one of the things I had to be really careful of with the processing the raw files into JPEGs to import into the video, was processing it so that you saw all the stars that moved but didn't see the little spots of noise that didn't move.
Mr. P needs a spanner.
Mr. P. Do I know Mr.
Yeah.
P?
You may have seen him in Jose's before.
Okay. If he comes with recommendations and references,
Yes,
well, okay.
Carl Edwards has vouched for him.
There you go. There's a spanner. If you call it a wrench, you'll lose it.
Anyway, on a side note, I've actually heard people saying that you should be able to see Sigma Octantis with the naked eye.
Who?
Yes.
Our pole star. in
We
the
haven't
southern
got a pole
hemisphere.
star. We haven't got an actual pole star.
Well, actually, that's one of the things I maybe I should have done with this video is even Polaris rotates. Even Polaris isn't dead on the celestial pole, so even Polaris has a little bit of rotation.
Yep.
It's about 3/4 of a degree.
Yes.
Mr. P wants to try to make me remember things like, what about when I'm on Crash's server or channel or whatever? Yeah, my memory's not that good.
Terry doesn't remember what he had for breakfast, let alone what happened yesterday.
I have to admit,
Exactly.
I do seem to recognise the icon for Mr. P. So I don't think I've seen him in somebody's chat.
Probably Team Skeptics. He's always in there.
Somebody wrote wrench.
Yeah, but
Oh, that's it. Dinky.
Yeah, you lost it.
That's a warning.
I put the warning out there. We don't have wrenches over here.
But hang on, she wants to be the wench with the
wench with a wrench.
Yeah.
Yeah, exactly.
Bar wench.
You can't. What's something that rhymes with spanner then?
Well, I was going to say you could be the.
Hammer?
Who said hammer?
Not me.
I heard it. Was that you, Elmo?
No, I know who it was, and I'm not saying.
Me?
Yeah, it was Elmo.
No, it wasn't.
No, it wasn't.
Yeah, okay. Any squeaky voice?
Wasn't me.
Oh dear.
Why does everybody hate me?
It'd be good if you could speak as high pitched as him. I'm not. My vocal cords can't do that sort of sound. Where's the crickets when we need them?
I don't know.
What do you got next?
Oh.
Nah, yeah, that's better. Alan, use your elbow. It might be easier.
Yeah. Sorry.
Oh dear.
And I've got the list in front of me. I've got the full list in front of me as well.
Well, turn
So
it around.
I really ought to
Turn it
get
around. It
right.
might be better the other way around. Well, we can keep chatting away like we're doing now, or we can watch, or we could watch something.
We could.
Or we could. Yeah, we could.
Mm.
We can either go to something serious or not so serious. Or Mr. Sensible has finally reached 1,000 subs, and he's put a
Nicholas, come in.
He's
Good
put
on
a
you.
he's put a special
Come here,
out,
Bubba.
so it goes for 20. It goes for 20 minutes. Oh
Can you
shit!
say gravity? Can you say gravity?
What is that?
You say gravity?
Daddy.
Good boy.
No, the Earth's not, and the Earth's flat.
And can you say the Earth's not flat?
It's not flat.
It's not flat.
A very sensible young man.
Yes, going to go very far.
Yes, my indoctrination is working.
You're going to be debating by the time he gets to kindergarten.
Oh yeah, he's going to have his own YouTube channel before he hits high school.
You'll be able to debate all the Anthony Rileys and
I was going to say,
all
actually,
them.
what I should
Sorry, Alan.
have played for him really is.
Hello, Flat Earth researchers, debaters, and debunkers. It's time to do some funny science.
Is that funny?
Are you funny?
Okay.
He loves all you guys.
Well, even though
I think it's great he did the egg experiment correctly as a preschooler.
Yes.
We are actually going to do a video on that in the next week or so, with him as my helper.
Fantastic. So hang on, let me get this right. He's going to do the
Riley
experiment.
experiment.
He's going to do the Riley experiment better than Riley did it.
Yep, without a parts per million meter as well. Because we don't fucking need it, because it's all about cause and effect of what happens if you add more salt to warm water. What happens to the fucking egg? It goes up because buoyancy is increased.
Oh dear.
There's nothing. All right. He calls it density, but density is about the mass and the volume. Okay? Not the state of the liquid. It's a fundamental flaw in his reasoning. Okay? The egg didn't increase or decrease in its density.
Did anyone see Ranty's the Sleeping Warriors presentation on Ranty's? How he was talking about that egg experiment and buoyancy and density and relative density, disequilibrium and stuff like that. Have you seen it?
You mean that word salad that didn't mean anything?
Yeah, but did you see that one on Ranty's just recently?
No,
Yes.
I didn't get
Oh,
that.
God.
I didn't get
Where
that.
he says that all you got to do is divide one by the other, like the density of the object by the density of the medium, and apparently it doesn't matter which way around you do it. Yeah, right. And he says, and the number you get, the number before the decimal place is the direction, and the number after the decimal place is the magnitude.
The what?
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 Yeah, exactly. What the?
What? Oh,
Yeah, the magnitude of what?
Yeah, exactly. I
The magnitude of the decimal place?
Yeah. So, I mean,
Maybe
if you get 5.4, that means you're going 4 in the direction of 5.
and you sure the dot doesn't mean anything?
I mean, is he getting confused with imaginary numbers?
No, he's just getting confused.
I think he's got an imaginary friend that told him the answer.
Come here.
Actually, he probably doesn't even have a clue what an imaginary number is, does he?
No.
What if it was turned into a fraction? What would that mean?
I need you to say, thank you, Terry.
No.
Come on, say thank you, Terry.
Terry.
Then you tell him.
You're welcome, Nicholas.
He's my little champion, that bloke.
As I was saying, he's putting decimal point as in for that, but what if it was a fraction?
Yeah.
Oh, jeepers.
I mean, like you divide one by the other, right? Well, if you get an answer of 1.2, that apparently, because the number is 1 or bigger, that's up, right? Up. And if the number before the decimal place is a 0, that's down. Okay. Now, what if you divide one by the other and you get 1.2? That's up with a magnitude of 2, apparently. But what if you do it and you get a thing of 5.0006? You know, that's up still, but it's a whole different magnitude, isn't it?
You lost me at the decimal point.
Yeah, it just doesn't make sense because, like, you can have a really small decimal thing after the decimal point. It just doesn't make any sense at all.
Oh, but it's relative density disequilibrium.
I bet you somebody out there believes it.
Oh,
yeah, Randy.
I could understand it if he was trying to do it as a complex number, but
hello, this is Anthony Riley you're talking about.
Yeah, I know. Sorry, I keep having this problem of falling into the trying to figure out how to make it work for them mode. Because obviously if you're going to debunk it correctly, you've actually got to know how it's supposed to work for them properly in the first place, haven't you? And this is something they don't understand.
Hey,
you could tell he was making shit up because, like, at one point he started to say, like, he tried to say neutral buoyancy position, but instead of saying neutral, he said nutritional.
It starts to make me think he didn't get his vitamin K shot when he was born.
Oh, we've got to play a snippet of this thing.
Oh, we need this video.
Yeah, where's me secretary? Go and put your dress on.
It's all right. I was sorting out a child.
Oh, okay. In what way?
Wanted more food.
They wouldn't fit in the cupboard.
Oh, couldn't get the box closed and the tape on in time.
Yeah.
Oh, so while your children are asking for food, mine's on here saying thank you, Terry.
Yeah. Pick the adult that's got a 4-year-old and pick the adult that's got teenagers that won't do as they're told.
I was just going to say, what someone's child knows knows better or something.
So what did you want, Terry?
Elmo was citing some
flat Earth nonsense.
Yeah, that'll do. Flat Earth nonsense in a video, and we might be able to play a bit of it just to extract any of the segments that were cited.
Mr. and Mrs. Secretary, it is Anthony Riley on Ranty's Roundtable doing his relative density disequilibrium.
I'm not sure if someone's already posted it.
Oh, I think we do have it. Is that the one that was put in our
homework? Yeah, it might be the one. Homework. Yeah, Ranty Flat Earth, Roundtable 24, relative density kicks gravity and bum sleeping warrior or something.
Yeah, that's the one.
All right, okay. So just give me half a moment. And
no, I've got it. I've got it.
You've got it?
Yeah, just grab that file out of the bottom of the cabinet for me while you're there.
Oh, the drawer's empty, Terry.
Oh,
that's not why he wanted you to go to the bottom drawer.
Oh, I'm not. Stop looking at my ass.
got a run in your stocking.
Oh, I have now.
We're terrible. Housekeeping?
Now this goes for an hour and 6 minutes, so shit.
So double speed and just skip bits.
Yeah. I can put the speed.
But you have to let us laugh every now and then.
Oh yeah, I'll let you do that. Playback
Yeah,
speed. Do you do it at 0.25 or 1.5? Because this 1.5 thingo that you were talking about before, Elmo, got me beat. Shit! Now is this too higher than 0.5, or do I go?
2's going in the direction of 0.
He can't get his magnitudes right over his directions.
Yeah, see, you got me totally stuffed now. I don't know what's going on.
Is it the real part or the imaginary part?
I'll go to 1.
It's far too complex.
Oh,
Yeah,
shit.
it's the real part of his imagination.
I'll pick a number. I'll pick 1.75.
So what are you looking for, Terry? The actual experiment?
Yeah, well, I was going to fast forward it through to anything.
I know where it needs to go.
It's just near the start, around about.
Yeah, give me the time. I'll be right.
Yeah, I'm getting there.
This is why we test these things right now.
It's impossible.
So if you start around about the 5:40 mark, go a bit earlier, go 5:30.
More decimal places again.
Oh, I'm sorry.
5:30, 5:28, 5:30, 5:30.
Yeah. Play it around there, just so we can laugh at him.
5:20, it starts nicely, I think.
Okay. Right, I'll pause it there. Pause.
Share the screen.
Yeah, I've got 5:20. I think I'm on 5:20. 5:30. Yeah, 5:17. There we go. Sound check. Share screen check. Scene selection check. Children talking in the background check.
Come here. Say Riley's a dick.
Well, he's sick.
Okay.
That's a proper little Aussie.
Yeah. Oh dear.
Oh
God.
Now all the big children, are we listening?
I think, hang on, before we start, I think we have to have...
Hello, Flat Earth researchers, debaters and debunkers. It's time to do some primary school science.
Okay, here we go then.
Do a sound check and make sure the sound's coming through. So I'm going to play the first bit. You should hear Rumpus talking. Interrupt me the minute you do.
A little squeaky part there.
Was that in the sound of this?
No.
Now that is a soundboard, but it was perfect timing.
Did somebody excuse themselves or go outside and shake themselves?
Oh, Royce Hart's in the building.
Now, children.
Sorry, Dad.
Don't make me get the paddle out.
That might have been just a bit too fast. That was a bit hard to understand.
Yeah, even I couldn't understand it. Well, I told you these decimal points have got me confused now.
Yeah, go 1.25.
Okay, I'll go 1.25.
Just a little bit fast.
But
yeah.
2.5 is bigger than a 1.
That's all right. We can deal with that.
Jeez.
We understand timing.
Do we?
I haven't got time for this, Terry.
You haven't?
So, okay,
you didn't share screen sounds, did you?
No, it's okay. I know why it is. This is why we test these things. Right, now, let me just do the
Don't forget, you can put your hand up and tell me to pause it at any time.
test now, see if you hear it now.
Yes, we do, yeah. Yep.
Very simple explanation.
Okay.
Yep, coming through. Right, I'm going to transition across, and I'm going to go on mute, and I'm going to leave it up to you.
Okay, so like I say, this is I feel sorry for Rumpus because for whatever reason his PC were acting daft last night. So I've had to edit all this out to get rid of all the ums and the ahs. So there's no deception, there's no intentions. I've just got it down to its most simplest form, and this is what we're left with.
That's a lie to start with. He says there's no lies and no deception. That's wrong, or that's okay.
Opening statement.
It was horrendous. So forgive me, but this is the best that I can do with what I've got. So here we go. This is Rumpus's point. It takes about 1.5 minutes.
Right. So you also need to explain. You're going to suggest.
Is he playing it faster, and we got played it faster, and now we can't hear it?
So you need to slow it down.
Is he playing it faster, or is it... Huh? Oh, the video? Oh, yeah. There's a normal, but I don't know if that'll work.
Go on.
If I go to normal, we won't hear anything. Sorry.
Come on, let's get on with the stupid.
What now?
Yeah, it's not coming through very well at all.
Hang on, let me turn the volume up.
No, not really.
An alternative explanation for ground.
How come he's having more technical difficulties than I do? This is weird.
It might be because
Who's having the problems? Oh, there we go. Ugly face.
Oh shit!
Few technical issues. Here we go. Try again.
Is that working?
As to how you can say
Far better. Right.
Right. Let me go to the beginning.
Let's start your presentation again.
Okay, so this is Rumpus's main point. It's only 1 minute 30 seconds.
Right, so you also need to explain. If you're going to suggest that this is an alternative explanation for gravity, then that's a very simple situation to explain. Now, imagine here we've got a ping pong ball being held down by a rod, and I then remove the rod. You need to come up with an explanation as to how you can say, having removed this stick now, the ping pong ball, which the average density, obviously the plastic, there's one density in the air is another, and then you have to explain how the relative density here, as you can see, we've got the ball at 1 and surrounded by all water. How are you going to then determine what direction this ball is going to go? There is nothing in here going over here or over here or over here. It's surrounded by water of that density, and of course, we've never ever seen an equation that gives direction. Right, so the point is, so here's the density tower with the various objects in it, and people like Anthony Riley are claiming that because these things stay in their particular point, you put an object here of a particular density, it will end up being in the relative density layer that matches its density. But that doesn't explain the situation, the dynamic situation here, where I've got this thing of a particular density. As I say, I released it. There is no relative density equation that will tell you what this ball will do, this ping pong ball in water. We all know what it will do, but there's no equation that anybody who believes in relative density can offer.
Okay, so that's the first bit. He makes 2 points. Basically, the direction. Well, we know that numbers are numerical numbers are, by virtue of the fact that they go up or down, they are linear. Numbers are linear.
What numbers?
They go up or they go down. And that's why we can use the phrase relative. So what I'll do now is I'll go to my PowerPoint.
4s.
Yeah.
He said relative.
Yeah, I got my hand up.
He's got such insight into mathematics. Those numbers, they go up or they go down.
Well, they can't go sideways.
Which number?
Yeah, exactly. In that presentation, there was not a single equation or number or anything showing a vector or a direction or an acceleration.
Yeah, but we know that he's talking about the relative densities. That's what he's talking about. The relative densities meaning that one's higher or lower than the other. But numbers going up and numbers going down?
We're learning to count with Anthony Riley.
Yeah.
Anyway, so far all I've seen is him look at Thingy's presentation and just dismiss it with the numbers go up and the numbers go down.
Oh, it gets better, Alan. It gets better.
This isn't even Sleeping Warriors' blooming own work. This is all done from Rumpus. Rumpus has done all this work so far.
I'm with the stupid.
Because this is not based on belief. I did not have this belief before I did my test. I just realized that if I added salt to this solution, the egg would move because I could change the medium, and if I manipulated the medium, I could make the egg move. Now, that means that no gravity is doing it. It means that I'm doing it with this density. Exactly the mechanism. I wasn't sure at the time. I now know, but I knew it wasn't. I knew what it wasn't because I didn't manipulate gravity. I manipulated the density of the medium. But this is not based in belief.
All right, fundamental mistake. He believes he increased the density when in actual fact what he's done is increase the buoyant force of the water.
Well, he did increase the density, but he also increased the salinity, the conductivity, the volume of the liquid, the resistivity, the viscosity, probably the temperature too. So he manipulated all of those things. So why is he hell-bent on saying that the only thing he manipulated was the density? Because he didn't. He manipulated a whole bunch of things, and out of all of those things that he manipulated, he just picks one and says, that's the cause. He's just presupposing. Hear that, Nathan? Riley presupposed that the density was the cause.
I might want to nominate this bloke for Bull T-shirt rest of the week with 3AW.
And he's gone on to cite all these things that he's increased, but there's one obvious thing that's decreasing. Can anyone guess what it is?
His intelligence?
No. The mass of that salt container, and he's decreasing the volume.
Does that mean he'll be able to hear it worse?
The total mass of the salt container.
Yeah, and here's the other thing too, right? I know it's further in this experiment, but you see him, he sees all the salt at the bottom of the water, and yet he still measures it, thinking that he's getting an accurate measurement of how many parts per million is in that water, when in actual fact, what he has done is he's increased a solid mass at the bottom of that water as well, which is actually...
It's actually raising the water level.
Because he's super saturated the liquid, so it's become a solution. And it gets to a point where the salt will no longer dissolve into it because it is so super saturated with the salt in it already. No more can be absorbed.
Yeah.
So once he gets to that point, he can add as much bloody salt as he wants, and all he's going to do is overflow the glass.
I reckon it's just so precious, though, when he puts that parts per million meter in, and he looks at it and says, I don't really know what these numbers mean.
They unicorn parts.
But it tells me what the density is.
Yeah.
No, it doesn't.
Like you said, though, Gravity. Like you said, though, Gravity. There's not an indication of any other scientific equipment, as he says. There's no thermometers. There's no, absolutely nothing else there except for this device that he doesn't even know how to use correctly.
Yeah, well, like in that experiment, if your hypothesis was that the density is causing the buoyant effect, right? Then what you would do is you would try and isolate all of the other variables, control all your other variables. So you would design an experiment where the density is the only thing that you're manipulating, not all of the other things as well, and you would isolate that as the cause.
So hang on,
But he didn't do that.
Isn't there a word that he always uses to describe the one element that you can manipulate?
Oh, the independent variable.
Oh, hang on. So that means you take away all the other variables, doesn't it?
Means you control all the other
control
variables.
Yes. So by his sheer ignorance of using a word incorrectly, he can't even perform a science experiment as he's trying to do correctly because of his own ignorance.
Yeah. And what's worse is he's not even doing it to his own warped imaginary version of science experiments.
Yeah, exactly what I was trying to get at, Alan.
Actually, I've got something Gravity will agree with. There's a couple of things that he needed to do before he even started this experiment. Weigh both eggs to check that they both weighed the same. So you've cut it. Yeah, you've cut out that variable. Also, to have weighed the glass without water, then to weigh the glass with water, and then to weigh the second glass to make sure it had the same weight distribution.
Okay? Well, I mean, if you're claiming to do an experiment where you're manipulating the density, wouldn't it be prudent to actually measure the, let's see, the density?
Yes.
And that's where he should be using a hydrometer, not a parts per million meter.
Yeah,
that's correct.
And hydrometers are really cheap and easy to use as well, aren't they?
Well, funny enough, you can make a hydrometer quite cheaply out of a big ballpoint pen and a small bit of lead shot.
Yep.
That's all you need.
You can go to the auto store and get a hydrometer battery tester for about $8.
True, but I don't think he's spent a cent on anything there. Have a look. He's pulled the eggs out of the fridge. Hasn't told the missus. He's used the water out of the tap. It's not even distilled or perfectly clean water or anything like that. So that means there's another.
Because didn't he put the ppm meter in before he put any salt in and got a reading?
That's correct. He's used tap water.
There are so many extraneous variables here. It may as well be a recipe for a pudding.
Exactly, that's right. To measure the density accurately, of course, what you'd do is you'd take a precisely known volume of the liquid out, and then you would measure the mass of that precisely known volume of liquid, and you'd calculate the density from it, which he didn't do.
No, and also he had 2 glasses of water, one which he preloaded with salt. So he'd already manipulated his independent variable before starting the experiment.
That would have been fine if he actually measured how much salt he put in there so that he could keep record of everything, in a data trail.
And he didn't measure the density of that water prior to putting the preloaded salt in. He only measured it against the one that didn't have the salt and the one that was preloaded. He then filled it with more salt and then measured it again. So he'd already manipulated the outcome.
It wasn't intentional. I mean, it's clear. It's clear to me, and I'm pretty sure it's clear to everyone else here that this is just he's eaten from the dog bowl, really, in this, and It appears that everything he's done here is just contradicted
He's
itself.
making it up
and,
as he
There's
goes
not
on.
much here. There's not much here for him to do. He doesn't know how much salt he's pouring in. He doesn't know how much hair is going to be left on his head by next year.
No.
Doesn't know if he's going grey. So,
Yeah.
honestly,
Doesn't know how many chins he's going to have by next Christmas.
Damn, I was going to say that.
depends on how much pudding you eat, isn't it?
He's trying to hide his chins with his really nice beard too. So.
Yep, with that nice beard, nice glasses, nice hair. Probably not going to have much by the end of the week.
More stupid.
But no, there's not much here. This is a bad pudding, and I wouldn't eat it because it's too salty.
Yuck.
Come on, I want to hear him say this stupid
science.
equation.
This had a valid hypothesis. It had a valid observed phenomena. It had a valid hypothesis. There was a correctly identified independent variable, a correctly identified dependent variable, and both these variables were valid, scientifically valid. There was a performance of a test. Then I was able to accept my alternative hypothesis. I rejected my null hypothesis. This is the backbone of science. This is not belief. So when Rumpus uses the phrase believes in relative density, you can test this yourself. You can get a pint glass.
Hang on.
You can pause.
So when you do a test, you're actually testing to remove other hypotheses. You don't actually test to accurately. If you make a hypothesis, you don't test to prove your hypothesis. You test to remove all other possibilities. So by the sheer fact
It's like
that
a checklist.
Yeah, so for the sheer fact that I've made a hypothesis and it worked, therefore I'm right.
And I've made a null hypothesis, which didn't happen, therefore I'm right.
Yeah, so he's basically got two sticks, tried rubbing them together, and he couldn't start a fire. And that's basically what's happened here.
Yep.
Oh, but his independent variable was it was raining.
And I think the dependent variable was him needing to update his PowerPoint to a more recent version.
That Windows 98?
Looks like Windows.
Looks like Office 2003, maybe.
It looks like XP or Vista.
What's that graph showing? Density of certain
liquids and materials.
Oh, I thought that was his brain.
I thought it was one of those lava lamps, to tell you the truth. But
similar principle.
Yeah, very similar, but different. And I wouldn't drink the crap that he's got in there.
No, but that's like oil red wine. I think there's
cherry tomato.
Yeah,
ping pong
marshmallow, golf ball,
and a bolt at the bottom.
Yeah.
Come on, you've got to move the video on so we get to the bit about the apple mathematics. Come on.
Come on.
Or a bit of salt in some water,
right.
And you can make that egg move. It's observable, it's repeatable, it's verifiable, it complies with scientific method. This is not belief. Now, Rumpus uses the density tower that we all use, and we all know, we're all familiar with. And for the purposes of this answer, I've changed the adjectives, the descriptions, these descriptive words with numbers. And they're all relative numbers. And basically, you divide one by the other. You divide, like the cherry tomato, by the density of the cherry tomato, by the medium that it sits in. And then you get a ratio. But it gives you both magnitude and direction, contrary to what Rumpus claims.
What?
Now,
what the fuck?
Yeah, okay.
Because the numbers are relative, it means that we don't even need the units afterwards. Provided the units afterwards are the same, like kilograms per meter cubed or centimeters or whatever, as long as the units are all the same, it don't matter. You can disregard the units because they're relative numbers.
Does.
Well,
that also means that you can then use one.
This is hurting my brain.
So once again, he's doing calculus with unicorn farts.
Yes, he's neglecting every single factor that he should be considering. He said, "Oh goodness."
It's the way he says things, though, too. Like he says, "You divide the cherry tomato by the medium that it's in."
Yes.
What? How can you divide a cherry tomato by water?
Oh, with a knife.
I don't know. The same way that you can divide Cummins by a cucumber.
But here's here's my dilemma. All right. He said, I've numbered all this, right? It goes from 2 to 13, and then the bolt's fucking 52.
Can I just
Where did he
point out-
get the number?
I'm watching this and the
He
cricket,
made it up.
and it's really making me angry about the cricket.
Come on, it gets better though.
One divided
I've
by
watched
the
this,
other,
it gets better.
interchangeably, you can do the cherry tomato divided by the density or the density divided by the cherry tomato. That's really important to understand that relationship because it means that, well, there is nothing else that you need to do to address the claim that Rumpus claims. There is no equation that anybody who believes in relative density can offer. Well, there is. So we're going to work through his example. Now, Rumpus has not been entirely honest because you can see that he's got the ping pong ball and he's given it density equals X. Well, ping pong balls have a density, and all you've got to do is Google them. Density of a ping pong ball, and it tells you, and you can check it yourself. A ping pong ball has a density
Stop.
and then it gives you a number.
Okay, another thing he's doing is he's generalizing every single ping pong ball on Earth. If in fact you want to know the density of the ping pong ball, how about you just have a little looky at the ping pong ball you're going to dunk underwater with a stick?
What's more to the point is, okay, so he goes to Google to look up the density of a ping pong ball. Well, funny, isn't it? If you look up on Google, what's the shape of the Earth? It tells you that the Earth is a globe, Riley.
So just
like spheroid word, doesn't it?
So correct me
Whatever,
if I'm wrong, though.
it's a ball.
But the ping pong ball, right? Now, not every ping pong ball's going to be the same. There are these magical words called tolerances that all these companies work within to make ping pong balls that are all within the same general area.
Yeah.
Oh yeah. Oddly, all sports have very exact tolerances for the sizes of most of the equipment that is allowed.
Also, here's the fallacy of Riley, okay? So what Rumpus has done here, okay, he's doing an experiment. Say he isn't using Google or an encyclopedia or anything like that. He doesn't know the value of the ping pong ball yet because he hasn't tested it. Therefore, the ping pong ball's value could be X, it could be Y, it could be Z. Until he knows that value, it's arbitrary. It is an X. And he's picking on it because he's gone, I don't know this value.
Hang on. I've got something more important to say. We've got someone naked in the side chat.
No, he's not.
Wasn't me, I've got pants.
He might be naked at the moment.
Oh, there he is. He's fixed.
Oh, sleepyhead.
Wake up, Jeff.
Hey, Knack, is your phone ringing? That's my ringtone when I get my new phone.
Okay.
On with the stupid.
Oh, I pressed the wrong button.
Number.
Good on ya.
You need that number. You need the units to make sure that the units of the density of water in grams per spit it out. Grams per centimeter cubed are the same. So as long as you're working in grams per centimeter cubed and grams per centimeter cubed, the numbers are what you need. So we know that the density of a ping pong ball is 0.084. In contrast, the density of water in grams per centimeter cubed just so happens to be 1. It's not really the best example to use, but as it's his, I'm going to use his because if I can use his own example, then I can't be accused of not answering the question precisely, comprehensively, and absolutely like full. So you need to know the density of the medium and the density of the object. They've got to be in the same units. As long as you get the number, And let's remember that the decimal places matter here. They matter a lot. As long as you get the number, that you need the two numbers relative to each other. To address or to answer the question that he makes, there is no equation that anybody who believes in relative density can offer that will tell you what this ping pong ball will do. Well, now we're going to show how it's not true.
You want to bet?
So, we've got the density of a ping pong ball, 0.084, and we have the density of water of 1. So long as both the units are the same, they don't matter. So you can disregard them, as long as they're the same.
What?
Because...
What? What do you...
What?
Disregard them if they're
Go
the same.
backwards a little bit. Go back 15 seconds. Go back
By
15
another
seconds.
value that have the same units, you do actually end up with something with no units.
Can,
Just units divide out, won't they?
as Terry's going back, can I just premise this question? If he's
Press
turned
J.
around, if he's turned around and worked out this wonderful formula to work out the density of an item, did he go and copyright it?
No, he hasn't. He hasn't come up with a formula to work out the density or anything. He's actually just looking up the densities of things on Google. So once again, he's relying on what other people are telling him regarding the densities. Okay, he hasn't figured those out himself. And then he's saying, well, okay, you just have to make sure that your densities are measured in the same units, like grams per cubic centimetre or kilograms per cubic metre or something like that. Because obviously if you divide kilograms per cubic metre by grams per centimetre, you're going to get a totally different number than if you divide something that's in grams per cubic centimetre by grams per cubic centimetre. So he's right there in saying that you have to have the same units. But you end up with a dimensionless number, which is quite meaningless, really.
But here's the rub, okay? He just spouted off the density of the ping pong ball and the density of the water being 1, density of the ping pong ball being 0.0084 or whatever he said. Therefore, you won't get a 0. So where's he spouting that the numbers would be the same?
No. He's saying he says there's no units to worry about because he's divided one unit by one thing with a set of units by another thing with the same set of units to get a dimensionless value. And
but that doesn't math.
Okay, I need to listen to this again. Can you play it again, Terry?
To each other. To address or to answer the question that he makes, there is no equation that anybody who believes in relative density can offer that will tell you what this ping pong ball will do. Well, now we're going to show how it's not true. So, we've got the density of a ping pong ball, 0.084, and we have the density of water of 1. So long as both the units are the same, they don't matter. So you can disregard them, as long as they're the same. Because these numbers are relative to each other, it does not matter which way round you divide. The answer will always give you both direction and magnitude, contrary to the claims of the rumpus. Always, they will always give you magnitude and direction. So it doesn't matter which way round you do it, 0.0084 divided by 1 or 1 divided by 0.084. It doesn't matter which way round it goes. Well, I've got one of the numbers is wrong there, but it doesn't matter. This is just to illustrate the point.
If you got a number wrong, your math don't work.
Oh my god!
Oh my god! So for a start, he's saying it doesn't matter which way around. Well, I'm sorry, but one divided by 0.084 is totally different than 0.084 divided by 1. For a start, they are two totally different results. So how can you say that it doesn't matter which way around you do it?
And then he says, "Oh well, this is wrong, but it doesn't matter."
Yeah.
I can do this on my whiteboard for the math for this.
You know what?
All right, time to get the calculator.
I think Riley is as uninterested in accuracy as I am over interested in getting in making sure that all the details in my videos are absolutely 100% correct. I really should chill out and learn to not worry so much, shouldn't I?
Yeah, you just got to chuck in the occasional, oh, it doesn't matter, Alan.
It's all right. It's close enough.
Yeah, it doesn't matter if I got this wrong.
Do we want to do a live calculation with a shared screen and actually draw the math out, show him that it's wrong?
No, I'll just pull the numbers. All right.
Well, we know that 0.084 divided by 1 is just 0.084.
Yeah. And 1 divided by 0.084 is 11.90476190448.
Look,
Okay, your calculator gets further than mine.
I'll be completely honest about this. I can tell you conclusively that this ping pong ball is going to go up. But it seems like he wants to go a different way about it. I can also say that my gentlemanly parts do float when I get in the pool.
Yes.
Showing the difference between density and that my gentlemanly parts are buoyant as they should be.
Also, you're showing how water sticks to a ball.
Ooh. Or balls.
And what happens is the number that you get on your calculator when you get it, the numbers before the decimal point give you the direction. The numbers after the decimal point give you the magnitude. And the further away they are, basically it tells you like what's going to happen. So any number that's greater than 1 is going to give you the direction in one way. Any number that is less than 1 will give you the number, but going the opposite way. So a number less than 1 is going to effectively give you up.
Going by those calculations that you just did by doing the numbers, that's saying that the ping pong ball could sink.
No.
Oh.
I think the ping pong ball is going to go sideways and break the glass.
And we know that up.
But I heard a but.
No, that was him. That was him.
Relative direction to the observer. Really, it's less dense. A number that's greater than 1 will give you down. Now, I have done this wrong here because I have put one less decimal point in, and they're important, these decimal.
So hang on. He said if it's a number greater than 1, it would go down.
Yeah, that's what I was.
And what did you get? You got 11 point something or other ... lots of numbers.
Like 11.9.
So why didn't it go down then?
Well, that's what I said. I said somebody gave the calculations a minute ago, so that means it could go down.
You say it had to be a negative number for it to go down.
And so that's the point out, that the bit that he said about it doesn't matter which way around you do the calculation. Well, it does matter, doesn't it? Obviously.
Well, either way round you're going to do the calculation, you're going to get a number greater than 1. It just, according to him, it's just going to matter how fast it's going to accelerate.
No, but one number equaled 0.084, but the other number ended up being 11.9. Okay, so the one that's 11.9 is supposed to go fucking down.
How'd you work that out?
That's what he said.
I thought if he said it was negative, it went down.
He said if it was greater than 1, it should go down.
Oh, we're having a math competition in the side chat now.
Well,
but that's not the most.
Watch that.
That's not the most alarming thing, though. The most alarming thing is the bit where he says that the thing after the decimal point is the magnitude. Because what if you divide one by the other and you get, say, a number that's 5.2, all right? And you do another experiment and you divide one by the other and you get 1.7. He's trying to tell us that the 5.2 is a direction of 5, whatever the fuck that means.
Yeah.
Right, and a magnitude of 2.
Yeah.
Right. Whereas the 1.7 is a direction of 1, whatever that means.
Yeah.
And a magnitude of 7.
Yeah. So that means it'll sink.
Yeah. So how can the 5.2 only have a magnitude of 2? And the 1.7's got a magnitude of 7. Well, what does that mean? What is that telling you about the thing?
Well, he's explaining it.
Oh.
And also, did you hear him? He goes, I put in one too many decimal points.
How can you put too many in? You only need 1.
Yeah.
He goes, one too many decimal points. Not places.
Yeah.
Points.
English not strong.
I've only just noticed it, but it doesn't change the fact. The numbers before and the numbers after give the direction and the magnitude. And so long as the number, so long as a number less than 1 is going to give you an up, or a number greater than 1 is going to give you a down, you always get your direction and your magnitude. But back to Rumpus's claim, there is no equation that anybody who believes, who practices in science...
Oh, we're going to start picking words now, are we?
Let's put that. There is no equation that anybody who practices in science, that would be me.
Why does he have to say stuff when I'm drinking me coffee?
Oh my God.
I nearly just went over my keyboard and ruined the stream. Oh, okay. Be careful.
I mean, I don't believe in God, but fuck me. Seriously. Get me a priest.
If he's a scientist, I'm a movie star.
Pornhub doesn't count, Terry.
Pardon?
I said Pornhub doesn't count.
No, have you autographed, Terry?
Who practices in science in relative density can offer that will tell you what's being done. Oh, I'm having practices in science. Anyway, you're supposed to be shush. So, basically,
we can talk.
Claim
Don't tell us to shush.
It's debunked because we can demonstrate it. You just divide one by the other, and then you interpret the numbers that you get in your calculator.
Oh, you interpret the numbers. You don't use the numbers straight out. You've got to reinterpret them. Okay.
Yeah.
Knowing that the first prefix is the direction and the second prefix or the suffix is the magnitude. That is the direction and magnitude. That will tell you what the ball will do. So, for instance,
give up.
Obviously, I'll use the one that's correct because I've missed off one of the zeros. 0.0084 divided by 1 gives you this. So that less.
If you miss a zero at the end of a number after the decimal point, and you got a number then a zero, that doesn't really matter, does it?
No.
Then 1 gives you up, and then the number is effectively like it's 840 or is it 8040, whatever. It's a massive number, so it's nowhere near.
That's a massive number.
840 or 8040, it doesn't matter, you know.
But how did he get that by timesing it or dividing it by 1?
Yeah, but where's the calculation for this? He's just...
Yeah, and where's the zeros to get him to 840 or 8,400 and whatever?
When I went to school, if you times anything by 0, it's 0.
Now, what he's saying is, I think I understand. I think
you think you
understand. It's very hard to get into the mind of Riley, though. You know, like if you do 0.084 divided by 1, you obviously get 0.084, right? Now he's saying that the zero tells you the zero in front of the decimal point tells you that it's going up, right? Up, yeah, not up, up, right?
Okay.
And the numbers after the decimal point, 0.084, he's interpreting that as, 840, 8,400, doesn't really matter. You get it?
It doesn't matter.
No.
He's dropping all the zeros in front of the first significant digit, right? And calling it 840. Or 8,400, depends on how many zeros you put after that 4.
Okay, Gravity. There's only one place I know where you drop zeros, and that's doing IPv6 when it comes to doing MAC addressing and that for hexadecimal numbers and stuff like that. Okay, so say you got a really long number and a bunch of zeros in. Like, so you've got an octet and it goes 0005. You drop the 3 zeros and make it 5. But that doesn't work in general mathematics.
No, of course it doesn't. I mean, you can't just look at a number like 0.084 and call it 840. I mean, that's ridiculous. But we are talking about Riley.
But that's manipulating numbers to suit your narrative and not actually presenting science correctly.
Now you understand what I was saying about what's the difference between if you divide the two numbers and you get 5.7 and you do another experiment and you get 1.2. I mean, does that mean that one has a magnitude of, I don't know, 770, 700? Whereas the other one has a magnitude of, well, what would you call it, 2? Could be 2,000, it could be 2 million. You know? Just whatever the hell you feel like.
So Riley is basically reinventing physics.
He's reinventing garbage.
Or more garbage then.
Near its relative density point. If this was like 0.9999, that's going to give you a really slow movement, like my egg. My egg will have been somewhat similar to that, 0.9999, because that was a slow movement. Because this is like 8.84, this is like so far away from its relative density equilibrium point, or its neutral buoyancy point, or indeed its maximum entropy point. They're all the same description.
Stop!
Entropy. I've
It's
heard of that
neutral
word
buoyancy
before.
point, or indeed its maximum entropy point, the same thing.
I don't know. I've heard of entropy before.
But hang on. How is an egg entropy?
Well, I mean, how can you bring like neutral buoyancy and entropy aren't even like related? It's got nothing to do with entropy at all.
And what's entropy for us people that are not educated?
And entropy is the measure of the number of microstates available to a system.
Yeah, and its capability of doing work.
So if you can think of all the atoms that are in the system, and you can think of all the little states that those atoms can be in, something with more entropy has more states available to it. Like, for instance, if you've got a certain mass of gas in an area, if you increase that volume, then you've got more places that gas can be in. So the entropy will be higher when the gas expands out into those spaces. That's what it's all about.
We can tell that this is going to go fast, and it's going to go up. And it's the same for the other one. Even though the numbers are wrong, it doesn't matter. It's still a big number, and the magnitude is fast. It's going up. Then now it's going down, and it's going fast. So again, direction gives you the prefix, magnitude gives you the suffix. As long as you can interpret what them numbers mean, you will always know what the ping pong ball is going to do in this situation. But remember, Rumpus didn't tell people that in the audience the density of the ping pong ball. That allows him to argue that you can't do it. To make people think that we'll...
Stop. Okay, so he's saying that the prefix, or what he really means there, is the numbers before the decimal point, and the suffix, which he really means the numbers after the decimal point. The example he used earlier was, what if I have 0.9999? Well, according to his own mathematics there, the magnitude of that is 9,999. And yet he was telling us that would move really slow. So what does this magnitude number mean? Does it mean that if it's big, it moves fast? If it's small, it moves slow? Or the opposite way around? Or what?
I thought they was talking about the numbers for the density of it would sink or float, not anything to do with speed.
Well, that's the number. That's the number before the decimal place, Terry. That tells you which direction it's going to go, up or down.
Oh shit!
But the magnitude, I don't think he really has told us what the magnitude actually means. Whether it means it goes fast or slow or what.
I'm glad I'm not trying to work this out.
Yeah, it's a typical hallmark of someone making shit up.
Gravity, by proxy, what he has done is he's equating magnitude to speed of movement through a medium.
Yeah, but he hasn't actually told us whether a big magnitude means a big speed and a small magnitude means a small speed or what. He's just said magnitude, speed, blah, 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 blah.
Yeah.
Just got to interpret it.
But the thing is he's already changed the magnitude by removing so many decimal places anyway.
Yeah.
We're watching that hangout. That there's nothing in this, and it's completely false. It can be done. You've just got to be honest with the figures, and then you can do it, as I've demonstrated. So, play second clip. It says, here we go. This is his second point to do with the vacuum chamber.
Similarly, if you do have an equation of relative density it involves dividing one density by another, which means if you have something like a vacuum with zero density, you will never end up with infinity. So this whole thing is complete and utter bollocks. And anybody who can't see that, I'm afraid, is a feeble-minded moron.
Okay, so he says that the whole thing is complete and utter bollocks, but he claims that if you divide something by...
I don't want to stop it on Riley's face.
Nicholas, say Riley dumb.
Mommy don't.
Did you get that?
No. Mommy don't.
by 0, you get infinity. Well, that isn't true, is it? So what I'm going to do, I'm just going to play this little bit again where he says this bit, because I want to hear people. I want people to hear what he says.
It involves dividing one density by another, which means if you have something like a vacuum with zero density, you will never end up with infinity. So this whole thing is...
So if you divide something by 0, you end up with infinity. Right, so let's go with the apples example. If I've got 5 apples, right? Normally I say if I've got 5 apples and I give you 3 apples. No, if I've got 3 apples and I give you 5 apples, I can't be left with minus 2 apples. That's what I normally say. Well, let's say if I've got 5...
Stop.
What? Apples?
So if Terry, if you give me $20,
no,
and I only pay you back $10,
I haven't got $20. Can you lend me $20?
All right, I'll lend you $20, but you only pay me $10 back. You still owe me $10.
Riley dumb.
Riley dumb. Yeah.
I so hope Alan gets some of those sound bites out of this.
Oh, I shall get some sound bites out of this. Do not worry.
Awesome.
So he doesn't want to believe in negative numbers now.
You don't mind me using somebody's voice for some of them, do you? Because he's so brilliant with his little words.
It makes you smile, doesn't it, Alan?
It does.
But if only we could get that inflection in his voice at the first time I heard him say when you asked, "Is the
I've got that recorded, Terry.
Yeah, that's so funny. That you can't beat that.
I've
you
got
cannot
that.
beat that.
Got to pass that on to Alan. Yeah.
Yeah, you got to get that inflection right in the sound. That's what makes it. Anyway, I need to reset my brain after this.
5 apples.
Will I get in trouble for indoctrinating my son into not believing in the flat Earth?
Probably.
Well, obviously you're going to teach him what science is and how to work things out mathematically and do experiments.
Yeah, well, my son already understands that shit falls, and you have to go, uh-oh.
No, it's not indoctrination. You teach him how to work stuff out for himself. That's all.
That's it.
Oh, he works. Hey, look, at the age of 3, he was saying the word parallelogram, for fuck's sake.
Shit, even I can hardly say that.
In the medium of 0, right? And I divide by 0, I've still got my 5 apples. I haven't got infinity, have I? I don't suddenly get all the apples in the world. If I divide 5 apples by 0, I end up with 0. Sorry, I end up with 5, but I don't end up with infinity. So Rumpus's claim there is totally false, and I can only presume that he's trying to mislead his audience by providing an alternative explanation that sounds ludicrous. And the way he presents that, it does. But if you divide 5 apples by 0, you end up with your 5 apples. You do not end up with infinity the way he claims. So that claim is totally and utterly fallacious. Is he trying to mislead people? I'm going to say he is. I don't believe Rumpus is stupid, but I do believe he's being dishonest and he's misleading people with false representations of mathematics that he wants to apply in a situation that doesn't exist. If you divide 5 apples with 0, you get 5 apples. You do not get infinity. Now, the third point is to do with what he claims, and I'll have to play this little clip because it's not too long, but this is to do with how the maths should be if we do the maths correctly. And in this case, I mean correctly according to Rumpus and the heliocentric model. So let's listen to what he says for how it should be, and then I'll just pull it apart really quickly, and it'll be done within the next 5 minutes.
Right, now...
Oh, by the way, this clip is less than a minute.
getting on to Anthony's egg thing. Hopefully this bloody thing start behaving. Right, so let's imagine I'm now going to give you the correct explanation of how buoyancy density interacts and how gravity gets involved. So,
Okay, he's now going to give us the correct way and how gravity gets involved. Now, at this point, I'm thinking, what gravity are you talking about? Are you talking about Einsteinian or Newtonian? Because obviously, since World War One, that's how long ago it was, Einstein replaced Newtonian. It's the curvature.
He seems to be hung up on these two guys between Newton and Einstein for some reason. What has he got? Has he got something against each other's
It doesn't.
stuff?
It doesn't matter who has what calculation for gravity. Gravity's gravity. It pulls shit to the center of mass. That's it. That's all you need to know.
Yeah.
Okay. So someone please correct me if I'm wrong. The major difference between Newton's and Einstein's method of working out gravity is that where Newton's calculations, generally speaking, work quite well on the Earth. They really do. The numbers work. It all magically works. Mm-hmm. However, when we go out into space and we need to work out gravity fields and time dilations and all that type of stuff, that's when we need to start using Einstein's form of working out gravity or formulas, because it's a lot more involved.
Yes.
Yeah.
Is that a nice and simple way, like from a layman? From a layman, you know.
Basically, if we're interested in things not moving at very high speeds, not near very, very large masses, and the Earth doesn't count as a very, very, very large mass in this instance, by the time you finished with Einstein's equations, you have Newton's equations.
Yeah.
As you say, as you start getting faster, and if you are trying to do things with high precision, say using a constellation of satellites to find your position on the Earth by transmitting the time from them, then yes, you have to take into consideration things like time dilation, as well as, of course, Doppler shift. But you know, not the subject of this conversation. But yeah, outside of that, or if you get very close to the sun, and Mercury, for example, is close enough to the sun that Newton's equations for gravity start to break down, which is why there was always a slight problem with Mercury's orbits using Newtonian gravitational equations.
Okay.
It's the effect of the curvature of space-time. Now, he hasn't said what he's talking about, but we know that he's going to apply weight. So we know he's going to be applying Newtonian principles, and they're gone. They were superseded by Einstein, and we all know what superseded means. Anyway, let's carry on.
So, if you can imagine this object, this egg-like object, in this water here, so I'm going to use this notation on the left-hand side here, where rho is the density, which is the mass over the volume, and weight is mg, as we know, which is the mass of the object times little g, which is the acceleration due to gravity.
So, weight, Rumpus is known for saying mass is not a force, weight is a force. However, on screen he has weight, the force due to gravity. Well, we know that gravity is not a force. Albert Einstein said in 1915, when he published his theory of general relativity, that gravity was the effects of the curvature of space-time. Gravity is not a force. Now, to make my point for me, I'm going to correctly cite George Musa. George Musa is constantly misrepresented by Rumpus. Let's hear what George Musa actually said. Now, I am conscious of copyright strikes for this ranty, so I've blanked out all the background so that it's physically different to how it was originally recorded. If there's any time where you think this might be a bit dodgy, just stop me and I'll stop it. But literally, it's his words. It's all masked out. We need, for educational purposes, we need to hear what he says. It is the total duration of less than 1 minute. And it's snapped up all the way through. It's like it's segmented as well. It's just the key points. But listen to what George Musa says about gravity. This is really important. If
Can you
Rumpus
pause
is going
it
to
before we go on with this? Right. Newton's law of universal gravitation. So it's not the law of gravity. It's the law of gravitation. States that every particle attracts every other particle in the universe with a force which is directly proportional to the product of their masses. Okay, so that's that two bodies in opposition of each other will have an effect on each other due to gravitation. And that's where his Fg equals G m1 m2 over r squared comes in. Okay, but these guys keep thinking it's the actual law of gravity. No, it's the law of gravitation. It's semantics. They get their wording wrong.
calculate weight with the force due to gravity. You can't calculate weight with gravity as a force. It invalidates weight as a calculation because gravity is not a force. It's the effect of the curvature of space-time. Let's hear George Musa's words in response or in relation to gravity and whether or not it's a force.
Right. So,
I should say though, I'm happy in a broader sense that people care, that this is a topic that people are willing to debate, even if they get some things wrong. I mean, we're all get things wrong in life, and that's not the issue. But to actually have a passion for understanding what is the nature of the universe, I admire. So I think there's a lot that's admirable in even though people I disagree with on the technical details. And Einstein's role here was to really fill in.
So at this point, he's talking about rumpus when people get things wrong. So let's hear what he says about Einstein in relation to Newton and in relation to whether or not it's a force. So that's what we're trying to work on. Is gravity a force? Because if it's not a force, rumpus cannot calculate weight using gravity as a force.
He won't let the person figure things out for himself.
His maths.
He's trying to seed your brain with ideas and preconceived things before he even speaks, which is annoying.
This is a passage from one of my relativity textbooks, right? This is interesting. Listen to this. Quotation or citation says, in a classical system, the equations of relativity, the geodesic and Einstein's equations, reduce to the equations of Newtonian gravity, Newton's second law of motion, and gravity. General relativity thus passes its most important test. In agreeing with Newtonian gravity, it agrees with centuries worth of experimental data. So there, right? That just destroys Riley's entire argument right then and there. It's
and all the flat earthers.
It's basically saying that relativity agrees with Newton.
Yeah.
Yeah, we know this, and George Musa definitely knows this. It's just that Riley doesn't want to hear.
Yeah.
It's also that they heard someone say something once, and then they latch onto it like a tiger eating its last meal and won't let it go.
That's part of their cherry picking too. They'll cherry pick what they, but not in the context of what it was said most of the time.
It's only stuff that fits their narrative.
Yeah.
Einstein's role here was to really fill in that mechanism. He explained how is it that massive objects, exert what seems to be a force on one another. Now, literally, it's not a force, but generally it's thought that Newton did not take his own law that.
So he's obviously just said, literally, it's not a force. Well, if it's literally not a force, you can't calculate weight with the gravity being a force. It invalidates your maths.
Okay, this is where Riley doesn't know words.
Literally, that there is a force reaching from one object out to another. However, you can act as if there were one. We can.
So it's literally not a force, but you can act as if it were one. Well, we all know any scenario. Ranty didn't kill his next door neighbour. And even if we act as though Ranty did kill his next door neighbour, that doesn't mean Ranty killed his next door neighbour. Even
False
if we act like
equivalency
it's one.
fallacy.
Yep. False equivalency.
So even though George Musser says gravity is a force and you can act like it's a force, that still doesn't satisfy the definition of force. There is no interaction, there is no push, there is no pull. And the final clip he says, this is the most important one. Think about this, what he says.
We can and do, and we must think of Newtonian gravity as a force. That doesn't mean it really is, but we don't necessarily need to work at the really is level.
So I'll close by asking the audience this question. Is the rumpus working at the really is level? We are. I am. Or at least I'm trying to. I'm not saying that I get everything perfect. But I am working at the really is level. Is the rumpus working at the really is level? I'm trying. That's the end of my presentation. Oops.
Right.
That's the end of my presentation. I've demonstrated that there is formula to calculate what's going to be happening to the ping pong ball. We do not need gravity or buoyancy as forces. Buoyancy is not dependent on gravity. Buoyancy is clearly dependent on the density of the medium relative to the density of the object in question. I've demonstrated...
Something has to pull that medium down. Okay, the only way you get up is by something working against you. I know it sounds arbitrary to say that, but that's how gravity works. Okay, a balloon, a hot air balloon, goes up because you've put warm air in it, and as we know, warm air rises. That's why it gets warmer as you go up in the atmosphere. But it's a buoyant force in the atmosphere.
Say that again to Alan.
It doesn't get warmer as you go up in the atmosphere. It gets colder as you go up in the atmosphere.
No.
Hang on. Wait. Hot air rises. However, as hot air rises, it loses energy by performing the action of going up. So the particles up higher are colder because they've lost the energy by moving up.
Yeah.
Yes. I was getting there.
Yeah. It's all right.
I was about to say about the particle spread when you get into higher atmosphere. But that's not what you see in a cup of water, because the difference between the top and the bottom of that cup of water is negligible. But ping pong ball will always frickin' float. Unless you put a hole in it, the ping pong ball will go up. And he's just dismissed it all without showing what the ping pong ball does.
The formula. It's a ratio, and it's simple. Doesn't need any further explanations, no further inferences. All of it is completely contained by dividing one by the other and correctly interpreting the results that give you both direction and magnitude. I'm done. Ranty, it's over to you.
Cool stuff, Tony. Cool stuff. Right, let me...
Now, do we have to skip?
Oh, is there really anything more to watch?
Oh, there's many more stupid comments in the questions, but I don't think we really need to go there. We've heard enough stupid from this one.
Yeah, the rest of it just looks like ranting.
Oh, the rest of it's questions from the chat.
Oh, okay.
Riley answers questions from the chat, and there are some classic moments in there too. But I don't think you really need to go there.
Yeah, no. Be typical questions and typical answers probably. Yeah, I'll skip a jump, and then we'll divide the jumps in between, and we'll just see what's being said.
Next.
Next, massive shout out to Sam Hine again, who's dropped another $20 super chat in right now, and it's a big up for you actually. Question for Sleeping Warrior: could you be any more awesome?
No.
Yeah, everyone seems to say that.
And he's modest
right,
too.
let me just get back to these questions. I'm having to keep up. So, yeah, that's just not what I'm looking for. So, the Adam Meakin. Dividing by... Shout out.
Shout out to Joshua. How high is a 10-foot wall? Go on.
Right. Dividing by zero is a concept to enable complex maths. It allows conceptual calculations not achievable in the real world. E.g., you can't share an ice cream between two people.
Yes, you can.
You can share an ice cream between two people.
Yeah, I knew you was going to say that. Okay.
One lick
But
each.
if I've got 3 ice creams and I have 4 children and they all want an ice cream,
Yeah, one of them's
them's
not.
Yeah, one of them's getting 0.
You poor bastard. Why couldn't you
I'll go
afford
back to
4
the
ice
apples
creams?
point. If I've got 5 apples and I divide by nothing, I've still got 5 apples. To be honest, Meek, and I'm not sure. I don't really get what you're asking there, because maybe this
Hang
is
on.
going into a realm that I'm not even.
So, as a father with children, and I'm sure I'm not the only one in this situation, if you had 4 kids and 3 ice creams,
I
you
can
get
solve it. I can solve it.
You get an extra cone and you take a bit off each of them.
No.
None of them would get any, and you'd have 3 ice creams.
No, I'd have one, and then the other 2 would have to be shared between the 4 of them.
Or you throw the 3 ice creams down on the floor, and they can fight amongst them, and the winner gets them all.
Well, no, I wouldn't be the stingy bastard who only bought 3 ice creams for 4 kids.
Exactly.
And-
Because you go to the bloke selling the ice creams and you say, I can only afford 3 ice creams, but I've got 4 kids. Can you make me 4 ice creams that fit the 3 ice cream limit?
Yeah,
that's
a way of doing it.
And that's what he makes you. Because, you know, who's going to be horrible to kid? Well, yeah.
Nathan Oakley.
Some of the people, yeah, I'm going to say some of the people working the kiosks in Great Yarmouth, yeah, they might be.
All right.
But
Anthony and his numpties like working with cameras, right? Does he know you can have negative focus?
No, I don't think so. I bet he doesn't know you can focus you can manually focus a lot of lenses past infinity as well.
But that's just
I don't know, maybe.
And I can manipulate all the numbers I like, so it sounds like I'm smart, but it means nothing in physics.
If you want to join, if you want to add him to the call, Ranty, and he can explain his point in a minute. I'm curious to wonder what he's getting at, because I don't tend to agree with him, if I'm honest, but maybe I'm completely missing the point, which is more than likely.
Well, I think Gleam said they'll come on. The Adam Meakin, I did message to ask if he wanted to come on. I know that I've got Martin Leakley coming on tomorrow, and I maybe Toadie will join as well.
Accounting for standard refraction at 76R when it's never, ever, ever 76R. Firstly, it's not based on a radius. It doesn't curve. It follows a deviation from straight in all directions, applying Fermat's principle on the trajectory of light. It deviates from straight. But why do you apply a curve? Who are you criticising here? I don't care what your maths is for your globe. It doesn't matter how accurate or inaccurate it is. What matters is it curved? And you tell us that this formula is supposed to be the way that we can calculate and test it. Well, if you're saying that's not right, you better correct all your peers that are telling us it's 8 inches per mile squared, because that's what we're working on. What you tell us is your model. So if it's not actually your model, let's hear what it is, Charlie, because I'm all ears for that. Are you...
I've been hearing this a bit lately about that formula for doing that. It's not entirely correct or something.
It ain't ours. It don't describe a freaking sphere.
It comes from the Zetetic Astronomy book by Robotham.
So why do they keep?
It was his.
Why do they keep accusing us of using it then? We don't. If we don't.
Because it says in their book to use that whenever we talk about the measurement of a round globe Earth.
But it can't describe a sphere because it's not. It's
the calculation for a curve, not a. I mean, for a
it's a
parabola.
It's a parabola. That was the word I was looking for.
Yeah, but these guys have obviously never done freaking calculus or done any form of plotting points on a graph. Okay? The moment you square something continually, it creates a gradient that gets sharper and sharper and sharper, whether you go up or you go down. Therefore, you get your parabola. But they don't realize that because they don't know how to do spatial mathematics.
Yeah.
You're going to move the globe posts again, like all ballers do.
From Pete Shea, what does he think of Geren's change of point of view with regard to gravity?
I didn't know he had changed his view. What is his view?
Again, it's something that would be new to me, so I don't know. But it seems that Pete Shea is aware of Geren's change in stance. Apparently, you're the only person promoting density and buoyancy at the moment.
Oh, right, okay. So in that context, I would say that Geren's the victim of political persuasion and pressure from Bob Nodell, because Bob Nodell practices fake science. He believes that gravimeters are demonstrating a downwards acceleration force, and he refuses to accept and acknowledge that you've got to manipulate your independent variable to prove a cause and effect relationship, which you cannot do with gravimeters. But for some reason, he wants to believe that there's gravity there. So if Geren's changed his position, I'm going to call foul that Bob's basically manipulating it because he's putting pressure on him. The reality is that egg moved because I put salt in it. That increased the density. That therefore increased.
He said manipulate your independent variable. Now I thought an independent variable was singular. Like if you can't manipulate the singular.
Look. Normally, you would fix all the other variables that you can and just manipulate the one you want to investigate.
Yeah,
but of course, you would have to. But of course, for a complete proper experiment, you would, when you're trying to find the basics, you would literally have to do repeated experiments manipulating all of the possible variables to find out what they do.
Yeah, that's what I was thinking, how it worked. Because a variable is just a singular of what you have, and then if you have a different variable, well, that's a different variable altogether.
The ideal experiment is where you only have to make one change to one thing to get the outcome you're looking for. Okay? And if you don't get the outcome you're looking for, you make an incremental change and test again. But what he's saying is that you can manipulate it all you like during the experiment until you get your result. But that's not how you manipulate the independent variable.
Yeah, that's what I was thinking. I was confused there.
Yeah, no, that's why I elaborated for you, Terry. I knew what you meant was that you don't make a massive change. You make a small change, see what happens. Make another small change, see what happens. Make another change, see what happens. But record every result. And then make your findings. But why is he accounting his egg experiment to gravimeters and gravity?
I don't know.
Increased the pressure from below, and that pushed the egg up. There was literally no evidence of anything else doing anything else. And if Bob thinks that there is, demonstrate it in science by wiggling it. Otherwise, it's nonsense, Bob. We all know it. You're the one that's preaching pseudoscience. If you've infiltrated Geren's mind and he's changed his position, we all know why that is. Shout out to Bob Nodell. Prick.
Okay, so from Marco Green, why do you think density relations manipulate objects' so-called weight? There's no zero weight of an object with weight, but density equilibrium between the object and medium it's in.
Run that by me again.
Run that by him again.
So So Riley doesn't understand Riley's own word salad.
Can we pause for a sec?
Yeah, we can. Yeah.
Can someone clear up a bit of a confusing matter I've got here?
You can get a cream for that.
No, confusing, not an itch.
Use your left hand.
Yeah, there's a certain company that might be in a bit of issues at the moment that involves Bob no clue.
Oh, Boob Noodle.
Yeah.
And Jism.
Yeah. Isn't Riley actually in cahoots with them?
Oh.
And he's just turned around and called him a fucking idiot or whatever he friggin' called him.
Prick.
Yeah. Can someone explain that to me? I'm a bit lost.
But how old is this? How old is this stream?
It's not that old. Let me.
Is it like last week, I think.
Is it before or after the
incident?
That's the word.
Yeah,
this happened. This stream of Sleeping Warriors on Ranties is only just recent. It's only a couple of days ago.
Exactly.
So, yeah, it's well after the FE. It's well after that notorious company's
incident.
Yeah.
Right. Do you guys remember what we did last night?
Yeah, and it was him then too. But
Yeah,
what I'm
remember
trying to
that-
get at, what I'm trying to.
Remember how he asked if we knew anything about FE Core? And we could call bullshit on him?
Yeah, but that means he's still associated with that company that will go unmentioned. Am I looking into this too deeply? Like, he's still associated with that company that did that thing that we won't talk about right now.
Yeah, I don't know. I don't know how far his association goes, though. I don't know if he's officially actually part of them or if he's just a.
He's a financial affiliated partner.
I can't confirm or deny that. I don't know.
His PayPal was opened by them because he couldn't open a PayPal because it got closed down. Because of suspicious actions on his PayPal account.
I thought that was Jism's account.
Yeah, it was not just Jism's.
Oh, okay.
Oh, that's why you're the secretary. You got all the information.
I do a little bit of fact checking occasionally.
So a few things pass your eyes, and you always read them to check what they are first, eh?
Yeah. So I just don't know why he would be turning around, other than, Bob No Clue turned around and proved that the Earth is turning at 15 degrees an hour.
And then stated gravity exists because of gravimeters.
Yeah. Other than that, I don't know why he'd have a problem with Bob being a member of being a director of the company that he's involved in.
They have a problem because Bob Nodell and Nathan Oakley had a run-in, and Nathan Oakley was saying that Bob Nodell wasn't following the scientific method. And, of course, Bob Nodell said he was following the scientific method. That basically Nathan Oakley is saying that Bob Nodell isn't doing real science when they're doing that notorious company's experiments. Yeah, Nathan Oakley's saying that's not real science because you haven't followed the scientific method according to the Oakley quantum eraser, scientific principles.
So I've got it now. So because Bob Nodell did an experiment that actually delivered the numbers that we would expect to see from said experiment, and he didn't like it, Bob Nodell didn't do it right.
Yeah, Bob Nodell's doing stuff that's not really science, apparently, according to...
He released the wrong numbers, the right ones.
No, he's just not doing science because he's not following the standard one and only true scientific method, according to Quantum Eraser and Nathan Oakley.
All right.
Terry, go get your coffee, mate.
What? 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 Just because I'm sitting here listening and waiting.
Hit play.
I can
Sorry.
turn. Do you want me to turn the volume down and then you can talk over it?
No, leave it off because not being able to stop it is a bad idea.
Yeah.
Yeah.
Because
Yeah, just go get your coffee. We can chat.
We
We're
can't
good.
talk as much as bloody Nathan can.
Yeah, but I can turn the volume down on the live stream.
No. Just
Don't touch anything.
We can
Okay,
talk to
I
the
touch
chat.
nothing.
Go make your coffee. We'll talk to the chat.
It's got another 9 minutes. 9 plus 6 is
15.
15 minutes to go.
I don't want to watch it.
I can
just
skip
don't
a bit
touch it.
more. No, I can skip
No,
it.
no.
No.
Don't. Don't panic.
Don't panic! Don't panic! Don't panic! Don't panic!
Okay, I'll press this button.
Go get your coffee.
I'll press this button.
Polluted.
That'll do.
Why do you think density relations manipulate objects' so-called weight?
Because it's relative density. Like I said, if you're at a swimming pool, you stand on a set of scales. You guys will tell us that there is a weight being exerted because scales are a force measuring device. Throw the scales in the deep end, then try putting your 20 stone on that scales. You're manipulating the medium. It literally, you can demonstrate it time and time and time again. That's the answer. You can demonstrate that this is what is going on.
Okay. From Brian's Logic, question, Anthony, would you agree that if a medium does not have the adequate structure to support an object's inherent density within the object's volume, then the medium won't support it?
Unless it's a solid, yes.
Okay.
Unless one of them is a solid, because you can have styrofoam that's very like it's not very dense, and you can put something that is more dense than the styrofoam on top of it, but because of styrofoam being a solid, then it will support the weight of the more dense object because it's solid. So yes, in general, but in practice we can demonstrate that less densities with less objects with less density can support objects with more density, provided they are solid and not able to physically move.
Tell you what, you are getting a fair few questions today. It's tough keeping up with these, but I'm trying. LBB Store says,
but that's our
if
Terry.
the current argument is at
He
an
wants to make us
impasse,
suffer.
do you agree accelerometers
In perpetuity
not affected by gravity
at
in bracket
95%.
are clear evidence that there is no underside to the mapped regions of our world?
I have no idea. What? Maybe there is. I don't know. I can see why there might be an underside. I can also see why there can't be. I don't know. I would rather just say I have no idea because I don't know how we would even test it.
Okay, so again from Ragnar Stefan Hallardson, can you predict direction, in brackets up and down, only knowing the density? Or do you need more information like where the Earth is?
Oh. Yeah, it's got nothing to do with it. It's relative density. It's got nothing to do with where the Earth is. You will tell where the Earth is based on the direction of the displacement, because if the Earth is below you, then one will go up, the other will go down, or less dense, more dense, and that will give you the direction in which all of these things line up. Now, if you're going to claim gravity, I may as well just claim God, because nobody challenges why hot goes to cold in the direction that it does. Nobody challenges why pressure goes to non-pressure in the direction that it does. It always does.
No, it doesn't.
Why do people challenge the direction for relative density? If you're going to challenge the direction, I'll just come back and say God, and I'm not even a religious guy, but I'll just come back and say God, because there's more evidence for God than there is for gravity. So let's have God versus gravity conversations, and let's see who wins that. I'll bring John in as my witness.
Okay, so this is an interesting question. Describe, and sorry, this is from
Here's a cock womble.
Crazations.
Womble of cock.
Describe how a siphon works using density and buoyancy instead of gravity.
I will.
It's just pressure disequilibrium. Sorry. What was it using instead of gravity?
Describe how a siphon works using density and buoyancy instead of gravity.
Well, you can't use density and buoyancy instead of gravity, because buoyancy is dependent on gravity. But you can have the density on one side of the pipe and the
Hang
density on the
on.
other side of the
Did you
pipe,
do
creating a
that?
disequilibrium.
just said
And we know that
gravity.
literally you can.
Terry,
We know
we need
pressure
to-
causes things to
What's the
collapse and
science?
swash
bloody hell,
and
Terry!
expand and burst.
Terry!
So if you've got more weight on one side of the pipe and less weight on the other side of the pipe, that's going to create an imbalance. You said anything about gravity or buoyancy?
He just admitted gravity.
I think they just wanted to see how it would
Yes.
theoretically work.
He just admitted you can't have buoyancy without
No,
gravity.
you don't need gravity or buoyancy. You just got all you need is that pressure disequilibrium. But Charlie says he says no, Anthony. The question of why heat flows from hot to cold is a major topic in physics. Yeah, but it's moot and it's not contentious in the shape of the Earth.
Nathan Oakley says, "Is this boring you, Anthony?"
Tired.
Nah, you better not be. You're going on an after show in a minute. From Gently's channel.
I might rage quit so I can go to bed.
Rage quit. Yeah, I know what you'll be up to, dirty boy. While his density math may look like it works, why do objects in low viscosity fluid all accelerate at the same rate? The math makes no prediction for this.
That's wrong. Easy. Who was that? Who asked that question?
It was Gently's channel.
So Gently's channel. If everything accelerates at the same rate in low viscosity fluids, why is it the egg doesn't accelerate at 9.8 meters per second squared? Secondly, in addition to that question, what force? If you're going to claim that there's a force that made the egg move, what force then made the egg stop? Because if it accelerates and then stops, an object at rest will remain at rest unless acted upon by a force. But once the egg starts moving, then an object in motion will remain in motion unless acted upon by a force. So you've got gravity pulling it one way to make it move, or pushing it one way to make it move. What's the other force then that makes it stop?
All right. Terry,
don't tell me gravity, but it flips around and becomes the opposite.
3 minutes.
Terry, we said don't play it when you went to make your coffee, but you wouldn't listen, would you?
I reckon it's about 3 minutes. He admits gravity.
I'm trying to find it. Uh, 5510. Terry,
Yep,
5510.
There. Press play.
This is from Crazations with a Z. Describe how a siphon works using density and buoyancy instead of gravity.
It's just pressure disequilibrium. Sorry. What was it using instead of gravity?
Describe how a siphon works using density and buoyancy instead of gravity.
Well, you can't use density and buoyancy instead of gravity because buoyancy is dependent on gravity. But you can have the density on one side of the pipe and the density on the other side of the pipe, creating a disequilibrium. And we know that literally we know pressure causes things.
Stop.
He just said gravity causes buoyancy.
There it is.
I think we need to edit that out and keep it.
Yeah, we need someone to do some edit too.
Yeah, Alan will do that. Don't worry. I'll grab it once it's. At least I know that it's 5510.
5510 it starts, Alan.
So basically from 55 minutes to 55:40. So that way you don't get him out of context and you actually get the question that's asked twice. And then he makes that Freudian slip.
He does, doesn't he?
So he is just a Poe. There we go. We don't need to debunk him anymore. He's just a liar. Fine. I'm happy with that. Move on.
Yep.
This is from Crazations with a Z. Describe how a siphon works using density and buoyancy instead of gravity.
It's just pressure disequilibrium. Sorry. What was it using instead of gravity?
Describe how a siphon works using density and buoyancy instead of gravity.
Well, you can't use density and buoyancy instead of gravity because buoyancy is dependent on gravity. But you can have the
There we
density
go.
on one side of the pipe and the density on the other side of the pipe, creating a
He
disequilibrium.
just
And we know that
said
literally,
buoyancy is
we know pressure
dependent
causes.
upon gravity, and he is the biggest proponent of density and buoyancy.
I reckon his defence would be. I misspoke.
No. He would have had his list of words.
Like he's done that in the past.
Said he misspoke.
Yep.
But he asked for the question to be said again, so he could then spout his answer.
Yeah, but I can hear it now. I was exhausted. You heard me yawn. I was so tired, I got my words all muddled up.
But you still said it.
I was tongue-tied because I was so tired. You know, my life sucks being a super cool flat Earth king.
Super cool flat Earth king. He
There's things
has
to collapse.
just broken the
Can
rule of thumb.
Can we send that to Bob Nodell? He'd love to hear that, I think.
We could probably, I could probably even find the bit where he calls him a twat or whatever it was.
Prick.
Oh,
a prick. Yeah.
Put them together, and what have you got? Another flat Earth fight.
Bob Nodell's a prick, and buoyancy requires gravity.
And squash and expand and burst. So if you've got more weight on one side of the pipe and less weight on the other side of the pipe, that's going to create an imbalance. Who said anything about gravity or buoyancy?
I think they just wanted to see how it would theoretically work.
You don't need gravity or buoyancy. You just got all you need is that pressure disequilibrium. But Charlie says no, Anthony. The question of why heat flows from hot to cold is a major topic in physics. Yeah, but it's moot and it's not contentious in the shape of the Earth.
Nathan Oakley says, "Is this boring you, Anthony?"
Tired.
Nah, you better not be. You're going on an after show in a minute. From Gently's channel.
I rage quit so I can go to bed.
Rage quit. Yeah, I know what you'll be up to, dirty boy.
Be up to rage
While his
quit.
density math may look like it works, why do objects in low viscosity fluid all accelerate at the same rate? The math makes no prediction for this.
That's wrong. Excuse me. Who was that? Who asked that question?
It was Gently's channel.
So Gently's channel, if everything accelerates at the same rate in low viscosity fluids, why is it the egg doesn't accelerate at 9.8 meters per second squared?
Stop.
Get over the egg.
And second,
Because the egg is not in a low viscosity fluid.
Yeah, I was going to
In
say
a high viscosity fluid. It's in water.
He doesn't know what viscosity means.
he'd have no idea what viscosity is.
He obviously doesn't know how to change oil either.
No, it's the next bit that I like. When he starts talking about the styrofoam.
in addition to that question, what force, if you're going to claim that there's a force that made the egg move, what force then made the egg stop? Because if it accelerates and then stops, an object at rest will remain at rest unless acted upon by a force. But once the egg starts moving, then an object in motion will remain in motion unless acted upon by a force. So you've got gravity pulling it one way to make it move, or pushing it one way to make it move. What's the other force then that makes it stop? Don't tell me gravity, but it flips around and becomes the opposite.
Okay, you've got two forces working against each other, Riley. The buoyant force and gravity are working against one another. That's why it stays in the middle of the water. You numpty.
Less dense the higher up you go. If I throw a ball as hard as I can straight up, why doesn't it just keep going up?
It's in the medium of air, isn't it? It's got mass and density that's greater than the value of air. It will get displaced because the medium can't support it. unlike the egg that is in a medium that can support it, and it doesn't.
To be fair, that was a malformed question, reading it back. It says, air is less dense the higher you go. If I throw a ball as hard as I can straight up, why doesn't it just keep going up? I mean, yeah, that's just the complete opposite of what you'd expect anyway.
Well, it's because as the air gets less dense, that object that you throw up is getting further and further away from its point of neutral buoyancy or its highest state of entropy. So why would you expect it to carry on accelerating if it's getting further away from its neutral buoyancy position? The only time it stops accelerating is when it gets close to its neutral buoyancy position or its highest entropy state.
Because you just said that
from a man like
less dense, if it's in a less dense environment, it will float.
Yeah.
You just said that the less dense environment that it's in, it would float. It would go up. So he's contradicting himself there.
Also, didn't he just say that entropy increases as you go up? That's a bit wrong.
Backwards.
The particles spread further apart the higher you go. Therefore, it's on a decreasing value? Or is it 1?
And gravity might correct me if I'm wrong here, but when you throw a ball up, it will continue up, working against the force of gravity until entropy, it uses up all of its energy going up, which is the entropy that it's using up.
Yes.
Then it has no energy left, so gravity can take full effect, and it comes back down again.
Yeah. Okay, so throwing a ball up in the air. Potential energy is what comes from your arm. The kinetic energy is the force as it's left your hand.
What if the wind blows it sideways?
Well, that means the ball goes sideways. Well, we're all screwed.
Newton's second law of motion.
Me, what is specific gravity?
I know what specific gravity is. I'll call it unicorn farts.
Is that what you want to?
Is that all he could come up with?
Unicorn farts.
Yeah.
But that's our word.
Alcohol unicorn farts. So obviously he doesn't care how much alcohol's in his beer.
No.
He doesn't care how much alcohol's in his wine.
Nope.
I do.
Oh.
Is that that's your answer, right?
I know what he's getting at, and I'm not going to entertain it because I'm going to just say it's unicorn farts. It's like a gravimeter. Gravimeters don't mean what they say that they mean just because the name indicates gravity.
Okay, right. So from John W. Does an electrostatic charge change the density of a helium balloon when applied to it?
I don't know. Test it and see. Maybe it does, maybe it doesn't. I don't know. Oh, actually, it does. Yeah, Zach showed it, didn't he? On Good Times for All. He showed that a helium balloon that was like a little bit more buoyant or less dense than the medium it's in, the air. If he put a charge to it, it appeared to get more heavy just by virtue of the fact that a charge was given to it. So I think the answer to that question might actually be yes, because we can demonstrate that. Shout out to Good Times for All.
Yeah, I was going to mention that to you, but yeah, it was an excellent video actually. Don't check it out if you get the chance. Good Tim's, it's Tim's. He hasn't put his E in, has he? So it's Good Tim's for All. Excellent channel. Gently's channel again. So okay, this is kind of it's one of these questions, but I'll ask it. Could you ask Sleeping Warrior, what's the pressure differential between Earth's atmosphere and 10 to the minus 17 torr?
Absolutely massive. We know that because the 10 to the minus 17 torr, you only need like a minuscule amount in change in pressure, and you can cause adverse effects on the human body. We've seen that demonstrated by, is it the Action Lab, who put his arm he tried to put his arm in a vacuum chamber and he couldn't make a good seal. And the minute he made a good seal, he literally broke the seal pretty much immediately because he couldn't create much of a pressure differential before his arm started to physically hurt. So the answer to the question is, how much of a differential is there? Put it this way, we can demonstrate that we can crush a tanker with half of it. And a tanker's made of steel, right? And it's reinforced, it's strong as bloody hell, and we can crush a tanker with half of it. So it's pretty strong. When you look at the vacuum chambers that NASA make, the concrete's like...
The tanker is designed to withstand pressure differentials of positively from the inside to the outside, not negatively. It's the same reason why spaceships can work and why submarines have such problems, because you've got to look at the direction that the pressure is designed to be held into.
That's why a sub can only go so deep, because the external pressures are greater than the internal pressures. Or part of it.
Yeah, pretty much.
Oh. 6 or 7 meters thick or whatever depth it is. That might not be accurate, but it's bloody thick. And when they put it down to the deepest vacuum that they can get, the air will literally bleed through the concrete chambers unless they've got more reinforcements to it. I mean, vacuum, the differential is vast. And what you guys say, oh, but it's not a negative value, who cares? It's not about whether it's negative or not. It's about the differential, and the differential is huge.
Okay, so I'm going to ask this sort of follow-on thing from Ragnar, and I'll get to you, Professor Phil Bell, in a minute. In other words, yes, the Earth defines up and down. I did not say gravity, only wanted to know if the Earth is a factor in relative density. I accept your answer, yes it is.
Well, the Earth is a factor because the Earth is more dense than the air. So, of course, it's a factor.
Okay, so from...
How does Riley know that the Earth is more denser than air? How does he know that? Is he using normal explanations, facts for that, or is he can't just say that with all this other crap that he says and then state something that is provable to be true?
Oh, come on, Terry, because if you put the Earth in the air, it would fall down to the Earth.
If you put the Earth in the air, it'll fall down.
Professor Phil Bell, how does relative density work for satellites?
Well, satellites
what
don't
it means when it
exist.
says satellites. You mean things that are supposed to be orbiting geocentrically around the Earth? I'm not sure what he means when he says satellites. Depends on whether he's a ball earther or a flat earther, that question. I'm going to assume he's a ball earther, and I'm going to assume that he believes that satellites are orbiting the Earth in space.
Well, yeah, he's actually responding to Lumberjack in the side chat, and he's actually said, putting satellites into orbit sometimes 36 kilometres from the Earth is his job. How does density do it?
They don't do what he's saying, but one sec.
Sure. I'll just do a bit of a dance in the meantime. Right, okay, so wait till Tony gets back. Wow, I think this is actually probably the most amount of questions I've ever...
Do you think Anthony might have just sort of like tried to use that tactic he said he'll be back in a minute, like to avoidance for a question?
Probably.
Also, going back to what is the difference between the 10 to the negative 17 torque? It's 14.7 psi, mate. That's the difference. That's the total difference between here and space.
You know the really funny thing about that? So if you got a inner tube for a car, opened it up so that the pressure difference between the atmosphere here was the same out, at sea level in comparison to in the inner tube, then you put the cap on so the air couldn't move and took it out to space, it would just blow up. It would just inflate. It would not necessarily explode like they believe.
But it would get fat.
Yeah, because the rubber would expand and stretch to suit the
Internal pressure.
Internal pressure.
Yeah.
It wouldn't necessarily explode like they think that it's such a great difference, and that's how the spacesuits can work.
Yeah, because they swell.
Yeah.
And they have a pressure inside the suit.
Such a short space of time. I think everybody's waiting to get their hands on Tony for some reason. Can't understand why. Let us know when you're back, Tony.
I'm back.
Yeah, I'm waiting to
Good
get my
stuff.
hands on him.
Good stuff. Right, we've run out of questions, funnily enough, at the moment.
Hey! Can I go to bed now?
No, you're staying up. You're staying up till 12:12.
I'm not staying up till half 12.
I'm having an early night.
I'll stay up 45 minutes. That's the most, because it's getting late and I'm tired and I don't need to do this because there is no evidence for gravity. You can't even define it, let alone demonstrate it or prove it. And if you can't demonstrate it or prove it, like I can with relative density, then it means that it's pseudoscience.
Okay, right. I'll just do. I'll do one last question from Crazitations again. What causes the pressure the pressure disequilibrium in the siphon?
The weight at the other end of the pipe. I'm assuming he means a pipe siphon. And normally, if you're going to suck diesel out of one tank to put it in another tank, and you might make sure that one's lower than the other, you've got to have less pressure on one side than on the other, and to create that, you have to lift it up. Let me address that guy there, Professor Phil Billy says. Ask him, how does relative density keep satellites in orbit? Right. Have you looked at quantum levitation? We can make big, massive aluminium plates, thick aluminium plates. Basically quantum levitate, and that looks just like an orbit over a flat plane.
How
does it work? Demonstrate an orbit. You tell me, you prove whatever these satellites you think that they're doing, just prove there's a satellite there and prove that it's orbiting Earth, then come back to me. Until you come back to me with a proof that there's something orbiting a sphere Earth, then I don't need to answer anything.
Well, so these video images and photographs of the ISS orbiting Earth is not good enough?
Yep, it's all fake. It's all CGI. They all dismiss it. It's all fucking bullshit, and they know it. They're all posed.
Right, okay, so here's the script. So I'm going to round this up, and then in 10 minutes' time, I'll be starting a chit-chat where I believe we're going to have Gleam join, for at least Gleam. So there's going to be at least Gleam and Tony. So, yeah, 10 more minutes. Tune back in. I'll start the show. And in the meantime, we'll end this one for now. Thank you, Tony, for coming along and doing this presentation.
I'd say that's finished.
Yeah, that's
Get rid of it. Get rid of it.
Yeah, close that one off. Bye-bye.
Yeah.
Oh, dear.
Much stupid there was.
What was that, Elmo?
Much stupid there was in that video.
Yes,
that was Yoda. That wasn't
the
Elmo.
stupid is strong with this one. His complete disingenuous, false narrative of we can use quantum levitation to make satellites float over a flat plane. Okay, quantum levitation is using magnets to make a piece of sheet steel, whether it be aluminium or whatever, levitate. How the hell do you get to levitate 400 kilometers in the air?
It's not even called quantum levitation anyway. It's really called quantum locking.
Oh, sorry for using flat earth words, gravity, but I have to use them.
No, I'm saying that Sleeping Warrior is using the wrong words. I know where he got the idea from. I can't remember who brought it up, but they were saying that silicon becomes superconducting at low temperatures. And seeing as the Earth is made much of silica, the crust of the Earth, that at the North Pole, where it's cold, it would become superconducting and the moon would quantum levitate.
Right. It's working on the same principle that if you if you get a pipe or something, a steel, or actually it doesn't need, not steel, needs to be copper or aluminium, so non-ferrous. If you drop a magnet down the middle of that pipe, the magnet will actually fall slower as it goes through that pipe because it creates eddies in the pipe.
Yep.
So it actually creates a very similar to like a transformer. These eddies work against each other. So as the magnet's falling down through the pipe, it's like the regenerative brake system on a car. You put the brakes on, and the magnets and the motors start working in reverse, and it charges up the battery. But instead of going into a battery, it goes back into the magnet, so it slows it down. This process can be used with a electromagnet and an aluminium ring, for example. So an aluminium ring being non-conductive, you can put that aluminium ring within the coil's magnetic flux and have that ring repelled from a magnet.
It's a pretty standard secondary school experiment.
Yeah, it's something that a lot of people do at secondary school. And they're trying to use that principle to justify why the moon floats. And it just doesn't work like that.
Oh, don't mind me. I'm just
Watching stars.
No, I'm just acknowledging people in the side chat.
Yeah, and you got the stars floating around too, Terry.
Yeah, I know. It's amazing.
Cool.
It's amazing. Well, I've either got Mr. Sensible or I want to know about this ISS thing about
so anyway, now we have.
Pardon?
Now we have.
Describe. I'm sorry. This is from Craze.
What have we got?
Crazations with a Z. Describe how a siphon works using density and buoyancy instead of gravity.
What's happened?
It's just pressure disequilibrium. Sorry. What was it using instead of gravity?
Describe how a siphon works using density and buoyancy.
Alan, you're sharing audio.
You can't use density and buoyancy instead of gravity because buoyancy is dependent on gravity.
Sorry? I was quite.
You're sharing whatever you're watching.
Somebody's sharing gravity.
I was playing the audio grab that I.
Oh, okay.
That's not me.
Yeah.
I was just playing the latest addition to my soundboard. I know it's 30. I know it's 30 seconds. Actually, it's 32.920 seconds long.
Elmo, what were you trying to share? Your name came up for sharing.
Oh, I was just experimenting around with it. I was sharing that quotation about Einstein and Newton and the gravity.
Okay. Yeah, it didn't come up properly on the screen before I shared it.
Okay.
You can do it again because I'm not sharing to YouTube, so I'll have a look at it and see why it's not coming up.
I'll try again and see what happens.
Yeah, you're not sharing to the outside world at the moment.
Cool.
Oh, you.
Let me try this one. So if I share that, what happens there? Can you read that or not?
Yeah,
I can read it.
Yeah, if I leave it at full screen.
So can I.
Yeah, it comes up. Comes up.
Daddy.
So I can share that and then you can explain it.
Oh, that doesn't work on the share though, Terry.
Why not?
You're only seeing the bottom left-hand corner of the grab.
Go to bed, Bubba.
So shrink it down when you share it.
No, I have to leave it at full screen. I think.
Yeah, it's way too big for the full screen share though.
However, we have done more than check that relativity requires Newtonian.
Yeah, it's coming through. That's right.
I like that little clip. That's beautiful.
That's nice.
It destroys Riley's argument completely.
Oh, Riley destroyed himself anyway.
How do I stop sharing?
Oh, I can stop it for you.
Oh, okay.
Or you can just go to the button that says "Stop Sharing" at the top of the screen.
Yeah, I've got it shared at the
In the
moment
top
for
of
the
the screen.
outside world to see what's written. So if you want to run through it verbally, what you're talking about, I'll leave it up.
Go on,
Oh, I
Gravity.
mean, it basically, it's pretty self-explanatory, isn't it? It says in a classical system, and by classical system they mean like non-relativistic, what we experience in the real world. It just basically says that the equations of relativity, the geodesic and Einstein's equations, that's Einstein's field equations, they reduce to the equations that Newton came up with. They reduce to Newtonian gravity, Newton's second laws of motion, and actual gravity itself. So they're saying that general relativity reduces to basically a force.
Nicholas, say Newton's gravity.
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 Newton's gravity.
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 Oh dear.
Come on.
I'll stop you sharing now.
Cool.
I know you went to bed.
Oh, she's sleepy.
Okay. Well, I want to listen to see what this is about to do with the ISS. So if anyone wants a toilet break or a coffee break before we do, because I've already had mine.
I'm just going to share something very quickly.
Okay. Yep, that came through.
Yes. Now, hopefully, everybody gets to hear this.
Describe, and sorry, this is from phrasations with a Z. Describe how a siphon works using density and buoyancy instead of gravity.
It's just pressure's its equilibrium. Sorry. What was it using instead of gravity?
Describe how a siphon works using density and buoyancy instead of gravity.
Well, you can't use density and buoyancy instead of gravity because buoyancy is dependent on gravity.
Go.
You missed a bit at the end.
It's sort of like at the end where he goes to say it broke up for some reason. It sounds like it didn't quite mesh.
Yeah, it didn't sound quite right, mate.
There we go. We're going.
All I can hear is
You
children.
mean I chopped it too early? Actually,
you probably chopped it a little bit too early.
You could probably also chop it a lot later because Riley re-asks the question, doesn't he?
Yeah.
And you could probably go from where he re-asks the question.
Mm-hmm.
But yeah, I just thought you might like to.
Yeah.
But I will.
We say hello, Nicholas.
Hello, Nicholas.
Hello, Nicholas.
Hello,
Everyone
Nicholas.
said hello.
Hello.
Say gravity.
Gravity.
Did you enjoy that, gentlemen?
Yeah,
that's awesome.
They're great when they're that age. Shame they grow up. Although I think mine's pretty good too.
Don't mind me, I'm just checking something.
I'm going to scare everybody.
There's Spooky put some facts for me in Fair Suck. 1, 2, something to do with physics. It's all above my head. No point in me reading it. I've heard about the laws of thermodynamic stuff. Anyone can elaborate on it, or
laws of thermodynamics?
well, he put entropy. He's got entropy at the top, and he's got one. He must have cut it out as something that's got an explanation in physics. A thermodynamic quantity representing the unavailability of a system's thermal energy for conversion into mechanical work, often interpreted as the degree of disorder or randomness in the system. The second law of thermodynamics say that entropy always increases with time. Okay.
Hank, no, that's misrepresenting the way the law is written.
Well, Spooky posted it. I don't know what.
Yeah.
Yeah, it's not a very good definition of entropy. That I wouldn't go with that definition at all, really.
Yeah. Sorry, Spooky. It needs to be able to be explained. So if I can understand it, then I can explain it.
Yeah. All right. The problem with the second law of thermodynamics is that it represents, as gravity has alluded to before in chats we've had, that it talks about microstates. But not only is it microstates of what particles and things can do, it also talks about energy and work and the availability of a system to perform work from the amount of energy it puts in. And if you break down thermodynamics, it does so many different things. But flat earthers just pick the one that talks about a closed system, but not that entropy is also used to create combustion. That's the capability of something to do work. It's not as basic as they make it out to be, and that's the problem.
I just don't like it when people like Riley throw in maximum state of entropy, and when he has no idea what entropy is really all about, and he throws it in randomly into some discussion where it's not even related to the discussion itself.
Yeah, and also he thinks people think of entropy the same way he does. Where's me Google at? No, not you. Don't want you. Too many people with too many thoughts.
How about some nice star trails? And a little bit. We could have the music too. While we're. That's a good fill. It's a good fill in.
So how are we all?
We are all good. Oh, look out, Rich has been out shopping again.
Oh dear.
Hello, gentlemen and ladies, if there is any.
They're on mute at the moment.
Yeah, the cops are behind me, so I'm just trying to be
Incognito, discreet.
Well, yeah, I guess.
Try to walk straight.
A little bit, yeah.
Well, just stand up and lean against the lamppost.
So we're not muted, but the music is.
No, I didn't mute the music.
All right, here we go. I will quote second law of thermodynamics, Wikipedia, even though it's got many, many bits in blue, so it's been edited. Second law of thermodynamics states that the total entropy of an isolated system can never decrease over time. The total entropy of a system and its surroundings can remain constant in ideal cases where the system is in thermodynamic equilibrium or is undergoing a fictive reversible process. In all processes that occur, including spontaneous processes, the total entropy of the system and its surrounding increases and the process is irreversible in the thermodynamic sense. The increase in entropy accounts for the irreversibility of natural processes.
Yeah, well, that makes sense.
I don't think it makes sense to you at the moment.
This is true. Yeah.
Yeah, but it's.
I'm very convincible at the moment.
Well, you know the ground you're walking on's flat, so the Earth's flat.
You know, that's why they make flat shoes.
And if you fall over, it's not because of gravity.
And are the stars spinning because the Earth's spinning, or is it because your head's spinning?
Yeah, okay, Rich.
You know one advantage of using a wheelchair, don't you? Your shoes last freaking forever.
He's on a phone, so if I share the screen for Alan's thing, would he see it on his phone?
Yes, he will.
Okay.
He just has to hold his phone sideways, I think it is. Where's Terry's car?
Oh, shit.
Yeah, I can see that.
Oh, sorry. Wrong button. Now, these stars aren't moving. They're stationary. See how they're not moving?
No.
Yeah, no, not really.
No, they're not moving. It's just it's a still shot.
That's Rich.
Are we talking about satellites, or is that what's going to move? Or
I don't know. What do you see?
No, I actually can't see anything.
You can't see anything.
Yeah, he has to turn his phone sideways for it to work.
No, I can see your car and stuff.
Huh?
Terry, you're sharing your whole desktop, not the window.
Well, what am I supposed to be on?
No, you need sharing.
YouTube.
Yeah, but
YouTube's only seen.
You're sharing the whole desktop to Zoom, not YouTube to Zoom.
Ah.
So we're seeing your OBS window, we're seeing your YouTube, your Chrome window, and parts of your desktop.
Yeah, and X and double X window, all of it, man.
Yeah, but YouTube's seeing the star.
Naughty boy.
Yeah, YouTube is seeing the stars.
Jeez. Is that the right one?
I'll be home in about 3 minutes, so you know.
No.
Now you should be seeing. No, that's not right. What's going
Now
on
you're
here?
sharing the chat.
Yeah, but why is that coming up? Something's not right here.
Oh, Terry, it's getting late, isn't it?
Oh dear. Try again. Press share. Oh, here we go. Now we should be getting. Oh shit. I'm just getting me orders all mixed up. Right, there we go. It should be right now.
Yeah, it looks okay, but we can see that you got a window open, XNXX.
No, it should be right now. I can't see. No, I've got everything right.
Yes, but Rich is probably having trouble focusing.
He's probably He's probably looking at the back of your phone. You got to turn it around where the screen is.
Oh fuck!
Yeah, and stop looking in that dumpster.
Yeah,
Right,
get out of the dumpsters.
Okay.
Right now,
Now,
what do you?
Rich has actually seen these stars, hasn't he? In real life.
Perhaps.
Perhaps.
Well, I'm pretty sure you've been up to this end of the world, haven't you?
Yeah, I have, yeah.
Up in the northern half.
What is that
Yeah.
thing on the left-hand corner? It looks like something floating there. It looked like something floating there, but it was probably a reflection.
Looks like a light post.
There's some lens flares in there because
I thought you were talking about Rich's live feed.
Oh, there's always a reflection of Rich's head, so don't worry about that.
We need to wear sunglasses when we're around Rich now. Are the stars out, Rich?
Oh yeah, of course. But I mean, the street lights are pretty bright down my street. So
okay. Yeah, light pollution's a bitch.
yeah, but I can go at the back and take a picture of something.
Can ya?
Yeah.
And we're talking about stars, though, aren't we?
Oh, are we?
I don't want to see any planets like Uranus or anything.
Okay, well that's awkward.
Yeah, and we don't want to see the sausage nebula.
Well, you know. Okay.
You been out to your friend's place again?
Yeah, and then had dinner and stuff. But hey,
yeah.
it's not about me. It's not about me.
Had dinner and stuff.
Stuff.
It's not about me.
It's not about me either.
Oh, are you serious?
Who wants to play Drink the Beer?
Me?
Dinky says I'm a star.
We know that.
In fact, I'd said joke fail. I don't know. There was a
Turn
joke
it off.
there
Turn it off. The lights on.
Oh, Rich! Shit!
No.
Oh my God! That's better.
I was getting distracted.
You almost broke the internet.
Look, I have enough technical difficulties here.
Ah!
You're lucky the outside world can't see that. So everyone...
Yeah, but even if they could, I wouldn't give a fuck.
Yeah. Where's that mute button for Rich? Knock, knock.
Who's there?
Rich.
Who?
Hello.
Oh dear.
Oh dear.
Now when we get
So
our
do you have-
now when we get all composed, we might move on to another video when we're ready.
Composed.
Yeah, I said that. Is there an echo?
Come on, bring on another video.
Okay.
Before I go to bed.
It is midnight.
It is. What us old people have to go to bed now.
No. I've got time for one more, like.
Just one more
misadventure.
video, Dad. Just one more.
Oh dear. These kids are unbearable.
Yeah, I know, but you're not up at 7 o'clock in the morning with a fucking 4-year-old, are you?
I've got a patient that rings me up at all hours of the night.
Oh, actually, speaking of patients, I have an update on my upcoming surgery.
Oh, okay.
Yes, it won't be a fusion. It'll actually be a reconstruction.
Oh,
that sounds good.
Well, they're going to pull it all apart like Lego and then put it all back together again.
Oh, sort of. They're pulling out a chunk of bone. They're moving a tendon from one side of my foot to the other side, and they're lengthening the Achilles tendon.
It's going to be the $6 billion man.
Yeah, I was just going to say that. You'll be able to.
It'll be about a $6,000 foot.
You'll be able to leap tall boundings with one leg.
Leap tall boundings. But yes, so my Wednesday involvement will be from a hospital bed.
Oh, we might have a live feed.
Oh, maybe if I turn the camera on.
You can show us what hospital food you get for dinner.
Depending on which hospitals he's at.
Also, I won't be getting dinner at 8:30 at night.
Oh, okay. No, you'll miss out on dinner.
I'll take some screenshots for you.
Depending on what hospitals he's at, we could organise to try and watch the surgery.
What? What, film it? We can film the surgery.
That'd be good content.
That would be good content, but I don't think they'd let me. Even though it is a training hospital. So,
They'll probably end up putting your bloody ankle on your nut on your forehead. Training hospital.
I was waiting for you to say they put their ankle on me nutsack.
Or the other way around.
Then I'll be able to kick you with my nuts.
Dear.
Okay, so where you put your shoe
on head. So, what does the wonderful Where's Wally have for us tonight?
He's saying that the ISS is losing its live feed of the Earth for some reason. So we're going to find out why.
I'd like to know why, because they were streaming bloody Hurricane Dorian not 2 days ago.
Yeah, but they can't last forever.
Oh, well, we'll find out. Rich, you got a funny looking cloud blocking the sun, underlit picture there.
Yeah, I know. It's pretty funny, right?
Oh, it's your head putting a shadow on the clouds.
Yeah. I got that picture, I think.
Oh my God, what is that?
Someone's feeding back.
What are you doing,
Not
Rich?
me.
I think it's Rich.
No, it's not me. I'm on headphones.
We're going to blame you anyway.
Yeah, and you like look at my head dance, like boom, 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 boom,
Yeah.
boom.
Rich, did you turn your phone off before you like, did you disconnect your phone before you got your computer on?
Nah, computers in the bedroom.
It's weird. All I see is his head moving around.
It's pretty fucking funny. I mean, I'm finding it pretty funny as well.
Okay.
Yeah. All I'm saying is like a dick. Yeah, I know, right? There you go.
With two eyes. It's a two-eyed one.
The problem is the feet, the street, you can't see it though.
Yeah. Yeah, I can switch the thing. Here we go. Click, click.
No, we don't need to do that.
There you go, everybody.
Yes, we do.
Everybody, look at Rich's head. Well, I'm going to play this. If you want to be entertained by Chrome Dome over there, you just can look over there.
Come on, play Wally.
Well, we need some sound.
G'day everybody, Where's Wally here? Well, I've just got one thing to say today. No. I guess
it's no!
There'll be more on this when we find out what's happening. Let's just hope the HD experiment isn't gone away for good. This thing has been lovely.
Okay.
Hey? There's no sound.
I said okay.
Yeah. It's his sound, not mine.
You just wait. Remember, there's no sound in space.
Yeah, but the camera's on the inside of the space capsule, the ISS, not the outside. What's that bright thing? We shouldn't see that.
It's Aristarchus.
Did you pause the video?
No.
The clouds are moving.
Even at 17,000 miles an hour, going around the Earth in 90 minutes, it still moves bloody slowly at that distance.
And the space station's going how fast again? Sorry. How fast?
Yeah,
is it?
but shouldn't the planet be looking like it's moving, because the space station should be flying, not stationary?
What?
Well, okay. Yes, the clouds would move slowly, but the space station moves at 17,000 miles an hour. We shouldn't still be seeing the same clouds in the picture.
You wanted to know how fast it's going, Terry?
Well, it said it's two times speed.
So the speed of the ISS at this present time is 7.66 kilometers a second.
That's fast.
That's pretty fast.
Yeah, I can see the Earth moving there with it, but the Earth's not moving. The satellite, the ISS is moving.
India's moon lander crashed.
It didn't, did it?
Yeah.
Yeah, I had a thing of it where
Bloody hell.
where they were showing it on somebody was showing inside the control room where all the Indians are all watching the telemetry for it.
So first the Israelis fuck up. Now the Indians fuck up.
It's a conspiracy, I say. It's a conspiracy.
Yeah, they're trying to get the tardigrades to mutate on the moon.
I'll stop going after the bloody that program. You'll get people cross with you. I mean, even just as a program for a program's sake, it had issues.
So is there any commentary in this?
I think we're just seeing the ISS going around the Earth at the speed the ISS goes around the Earth at. Because it's a long way away, it looks pretty slow, even at 2 times speed.
Yeah, but what was the name of his video?
He was saying something about the live feed was going to be stopped for some reason. I thought he might have been talking about that part of it. Not just showing us this.
This is like...
There's no sound. I've got the sound on. Unless he's commenting and the sound's cut out or something on him.
No.
Well, this is enthralling. I could fast forward it manually on the keyboard, but I don't know how far I'd move it.
Oh, naked person in chat, Anthony Bailey.
I don't know an Anthony Bailey.
Anthony Bailey?
Yeah.
Oh, he's brilliant. He did my intro.
He did an intro?
Yeah, he did the intro for my videos.
Did he?
Yeah.
So is he worthy of a spanner or a wrench?
He's definitely worthy of a spanner.
You need to give him both.
I didn't think we gave out wrenches. I thought we only had spanners.
No.
Give him a spanner.
Yeah, I'll give him a spanner.
He deserves it.
If he says thanks for the spanner, he'll be good in my books.
No, well, you have to give him the spanner first.
Yeah, I gave him a spanner first. Well, the rest of this is just this feed. That's all it is. Funny you say that. Every time we chat, thanks for the spanner. What, funny that I say that every time? Or who's that person?
He says, funny you say that every time we chat. Yeah. Thanks for the spanner.
Terry forgot he got coffee 15 minutes ago.
Yeah.
Did I forget?
All right. So this Where's Wally video
coffee.
was a bit of a dud.
Yeah, I'll just skip a bit.
I think the thing is that the instrumentation package that's got the camera on it that they use for this is now end of life.
Yeah.
So
I bet you they're going to replace it. They'll replace it.
I'm a
Oh,
sub
yeah, I'm sure they will.
And I'm a sub on Anthony Bailey's channel. Jeez, I can't remember where I've got me spanners everywhere. I'll have to count them one day.
Yeah, because the 14 people in chat are very hard to count.
Oh, okay. Oh, well, that was your entertainment.
Can we have another video? Cause
Yeah, you can have another video. I don't mind.
That was
there. Okay.
Couldn't even masturbate over that one.
Should we have Mr. Sensible or whatever it was that started with Nathan?
Well, I've got here, I bet you didn't know that a baseball can disprove Coriolis effect. Did you?
Yeah,
Me
do that
neither.
one.
That sounds good.
Yeah.
It's Mr. Ape Man.
The Indian moon, the Indian
Blue marble.
moonlander, the Indian moonlander lost communication just before landing.
Oh, no. Oh, we won't see any live feed for that. Now, see if we can get this right.
It's blue marble science, isn't it?
Should be that
Him and
one.
Gladys.
There we go. Oops, shit.
Yep.
Oops, I forget to press that one. There we
Sound.
go. Sound, yeah, I got sound.
And play.
And we got play, and we got press.
I bet you didn't know that a baseball can disprove the Coriolis effect, did you?
No.
Well, me neither. But Mr. Roberts is convinced that he has solid proof that that is true. So we're going to watch a little of his video and see what you think. By the way, I apologize for the quality, but that's the way it came off of YouTube.
That direction that way is the east. This direction that way is the west. We got north back here. We got south that way. So I'm hitting it north. Now, if we were truly spinning on our axis at over 1,000 miles per hour, that alone should allow for the ball, when I hit it straight up into the air without really any wind catching it or any spin of the baseball. If it's,
I'd like to just make a correction there. He said 1,000 miles an hour. Now, it depends on his latitude, doesn't it?
Yes.
just straight, in a straight spin, then what should happen is that the ball should land like way over that way to the west.
You don't seem to be off to a very good start, Nathan. You understand that the Earth is rotating from west to east and at your latitude maybe 800 miles per hour. But you've got it in your mind that if you hit a baseball due north, even though the ball had the Earth's 800 mile per hour velocity when you held it in your hand, it's going to magically lose all of that velocity and come down someplace to the west of the ball field. That is exactly ass backwards, buddy.
Okay, wait, like it should go outside of the baseball field. Okay, when I hit a high enough pop-up. Let's see if that happens. Okay, let's check it out and see if the 10 and 8-year-old have to know anything about Coriolis in order to figure out how to catch a baseball. Let's see. All right, ready? Who's first? Here we go. Straight north. And while I hit it way over his head,
you
it did not
arsehole.
land
Just hit yourself with a
out
bat, will you?
of the field to the west. You know why? Because the Earth is not spinning. Ready?
I wonder how many takes it took him to hit the ball, though.
Here, Montgomery.
Smash it with your head. Smash your head with a bat, dickhead.
If he really understood the Coriolis force, he'd know the ball would actually go the other way.
And it pushed the ball that way just because of the spin of the ball.
Yeah, I was going to say the same thing.
Look, he just proved what Coriolis does. The spin of the ball made it turn.
That's not Coriolis.
Yes, aerodynamics, but I mean, it should go the other way.
That's why a golf ball's got dimples in
and
it.
over the distance that he's actually doing this in,
Look, the
Like
land
it's
somewhere
less than
that
an
way,
inch.
because that side of the Earth is coming to bunk. It's not spinning. That's right. Well,
Those poor children.
if it was an if, not that it is.
What we've got here is failure to communicate.
There you go. There we go. That's another good pop-up. Straight up. And it's stayed inside the baseball field.
If we have a ball at the equator, for instance, we know the ball is moving about 1,000 miles per hour. That's the rotational speed of the surface of the Earth at the equator. When we strike the ball in a northerly direction, it still has that 1,000 mile per hour rotational speed associated with it, but as it moves north, the rotational speed of the surface of the Earth is decreasing. The ball will not go straight north. The ball still has that 1,000 mile per hour rotational speed associated with it, and it will deflect to the right. It will end up east of the field, not west of the field.
These are simple tests, guys. You really have to be willfully ignorant to choose not to believe your God-given senses.
No, Nathan, willful ignorance would be ignoring the mountains of evidence we have that show the Earth is rotating, ignoring things like the stars rotating in opposite directions around the two celestial poles, ignoring the Coriolis effect, which we can measure with hundreds of Foucault pendulums all over the Earth, ignoring things like gyrocompasses, again, that will not work unless the Earth is rotating. And the sunrise and sunset, well, that's another issue. You guys still can't show any reasonable way for that to happen on a flat Earth, but I'm not going to get into that rant. What I wanted to do was a real quick and dirty estimation of how much deflection a ball should see if it flies, let's say, 150 feet. So this is an approximation. I'm not including effects of wind or air density or the actual elevation or any of that sort of stuff. This is just a rough and dirty way of doing this. If we start with that baseball at exactly 35 degrees north latitude, the surface of the Earth has a speed of about 852 miles an hour at that point. If we make the assumption that the ball is going to travel 150 feet and have about a 3-second flight time, it will end up at a latitude of 35.00041 degrees north, and again the speed is just slightly less, 852 miles per hour, but a little bit less than it was at 35 degrees. The difference in speed in feet per second is 0.0063 feet per second. That's not much. So what does that mean? Well, it means the total deflection in that 3 seconds is 3 seconds times 0.0063 feet per second, or about a quarter of an inch. A quarter of an inch. And you know, that's remarkably similar to the number that Neil deGrasse Tyson came up with for the football. And he did that off the top of his head. In a television interview. I'd say that was pretty good. But you know what? I think that'll be about enough flat earth crap for one day. Thanks for watching, everybody. I hope you enjoyed it. If you did, hit that like and subscribe button right down there under
Already
the
have,
red.
mate.
Yeah, already have.
How good's Big Blue, eh?
Oh, yeah.
Yeah, less than a quarter of an inch movement over 150 feet.
It's not a lot.
So,
It's not a
yeah.
lot.
How was he expecting to get any form of Earth movement over that distance and see it? They always go from one extreme to the other. Either you can see it or you can't see it. There's no in between.
What, they'd think that there's no atmosphere or no gravity or anything like that to affect it.
Well, Anthony Riley knows there's gravity. We already worked that one out.
No. Yeah.
Oh, I wonder if Rich has seen that.
I'm not playing that again. Oh, we've been going for 3 hours now. I think we've hit our
limit.
Yeah, our brain needs to recuperate.
Oh, it needs to unRiley.
Yeah, unRiley. That's. Oh, thanks again, Alan, for your Star Trail capture.
That was brilliant.
That was great. That was. I can imagine the amount of effort it would have done for the editing and everything. So that's the best part. I think once you're able to put it all together. How many shots was there in total?
Alan?
Alan?
Alan
Alan?
might have drifted off.
Alan?
Yes.
Alan?
Steve?
Steve? Don't panic.
All that praise, and he missed it.
I was just praising you for your excellent Star Trail capture and putting it all together. That was a great effort.
Thank you.
Then I was asking how many actual individual images it took to make up the complete fully edited version.
I can tell you that it took lots. It took the first one, the longest one, the one that's darker, took 2,000 images. The other shorter two, one was 1,200 images and the other was 1,400 images.
So in total, almost 5,000 images.
Yep.
To make 7 minutes of video.
That's a lot.
No, that makes about. Well, it depends on what speed you play it back at, what frame rate you play it back at. The video is that video is actually uploaded in 4K and 60 frames per second. So that lot makes about 1.5 minutes video.
Wow.
Wait a minute, I'll pause it back on the text I read. There, here we go. Run 1. Second system test. 3 hours, 29 minutes, 16 seconds. Okay. And all that other stuff, I've got no idea.
That's the camera. And it's shooting at 0.1 frames per second.
At playing at 600 times speed. Wow.
So playing it back at 60 frames per second is 600 times speed. And
yeah, the first bit.
Yeah, there's
I missed the first bit.
There's just over 2,100 frames in the first one. No, there's just on 2,000 frames in the first one. There's 1,200 frames in the second and 1,400 frames in the third.
The first one took 5 hours and 51 minutes.
Yep.
And where's the second one?
With a photograph taken every 10 seconds.
And the second one's 4 hours and 5 minutes. Wow.
Yeah, and the third one's...
Is there a third one here? I didn't see a third.
No, that's the third one. Run 2 is the third one.
Oh, okay.
It's 4 hours, 5 minutes. And run 1, which is the middle one. Because it was testing, I started it at run zero. So the very as the video actually opens, you get the details for run zero.
Yeah.
They're very similar. There were some things I forgot about the camera, which meant that the first one, the camera settings were not the optimum ones that I was wanting. The thing is, because the lens I have is fully extended when it is zoomed out to wide angle, if it gets pressed on, it tends to make it zoom to a longer focal length, which is why the first one is shot at 37 millimeters instead of 20. Because it gets pressed almost all the way in.
Oh, I wish I had a camera. I could do the same thing down here. But I couldn't do it where I am. I got too much light pollution.
Yeah, well, I'm quite lucky because I was actually able to do that on my front porch.
Yeah. Well, you are away from the main town, a fair way.
Yeah, I mean, I'm in a reasonably good light area.
Yeah, rural area, yeah.
Apart from when the security light comes on the house opposite and shines on the and is able to shine directly onto the front of the lens and makes it flare.
Mm-hmm.
I believe that's where the lens flares came from.
Yeah.
So, Alan, just so that you know, in the chat on the side, I'm posting the link to your channel, which you have other videos and live streams.
Yes, and I shall be putting this video to public when we have finished the stream.
So that way, anyone out there that hasn't subscribed to Alan, please subscribe and check out some of his videos. They're really good. He's done a few live streams and other star related videos.
I shall hopefully be doing some photography tutorial type live streams in the near future.
Okay.
Because I know there's at least one Southern Hemisphere person who wants some help with his camera. So that will probably get live streamed onto the internet. Seems like a good idea.
Yep.
Sounds like a good idea, Alan.
Yeah,
So, Alan, Dinky Died Gone in the chat on the side mentioned that you haven't got a Nikon P900. So could you just to give a bit of an explanation on why your setup 4 stars is better than a Nikon P900?
Well, the most important thing when it comes to getting light from very faint objects is the size of the buckets you can collect the light in. Because the bigger the area that you can collect the light over, the more light you're getting. And the sensor in my camera is approximately 22 by 15 millimeters. The sensor in the Nikon P900 is approximately 7 times smaller than that.
So yours can actually get more light in, which means you can get a more high resolution picture.
The resolution is about the same. My camera is a 15 megapixel camera, but it's looking at light over a much larger area, so it gets more, so you get more photons. Literally at the point we're at here, you are looking at counting photons almost. So the fact that you can actually get more photons arriving at a point gives you a big advantage in what they call signal to noise ratio. So I get a bigger signal per pixel than a camera with a smaller sensor. Of course, one of the things that it is difficult to do is to zoom in on things, because the P1000 or the P900 has a field of view that is equivalent to using a 2000 millimeter lens on a 35 millimeter camera. The P1000 has the equivalent of a 3000 millimeter lens, but the P1000 only has a 500 and something millimeter lens. The P900 has a 375 millimeter lens. I actually also have for the camera, I have a zoom lens that zooms from 150 to 600 millimeters. So that is an actual 600 millimeter zoom. Because that's on a slightly smaller than 35 millimeter sensor, that has a slightly narrower field angle of view, so that's equivalent to 960 millimeters. Now, I can also crop that image a bit more. Okay, I lose pixels, but the image isn't as noisy. The image has a lot more integrity, one would say, and I can actually get good results up to an equivalent of 1440 millimeters, equivalent to 35 millimeter sensors.
Wonderful. Yeah, no, that's it's the difference between, well, I suppose it's horses for courses.
It's horses for courses. If you want super duper really long range images, then yes, you might want to go for a Nikon P1000. But if you are interested in a good quality image, so the image I'm now sharing, if Terry can put that through to the public. That was taken with my 150-600 millimeter zoom lens, and that has been cropped to give an equivalent field of view of a 1440 millimeter lens.
Okay.
Yes, I'm only at 8 megapixels, but I can still blow that up and make that a print that is 5 foot across. Is like, you could probably blow that up to a 2 meter print. at a quality where you would be able to literally walk up to it and look at it as close as you can get your eyes to focus.
So what you're saying is that it all depends on what images you want to take.
Yes.
Lovely.
Of course, I'm always wanting to buy more lenses and stuff, but you know, unfortunately they ain't cheap. I was just looking at a really nice zoom lens that would make the wide field images wider, and you know, a second hand one is £279, and the new one is £479. So that's kind of out of the ballpark for me at the minute. As is at the other end a doubler, a 2x teleconverter to go on the back of my 600mm lens, which will make it 1200mm and get me over the equivalent. You know, get me up to an equivalent of 2000mm on 35mm. Or almost, yeah. So it would get me the same field of view just about as a P900. But one of those is nearly £300.
Nice.
But then when I got that zoom lens, it was £1,000 lens. It's come down a little bit now, a little bit more now. Now it's a £800 lens. So $1,600 US. Sorry, $1,600 Australian. Although I think it's closer. Although I think actually in Australia it's closer to $2,000.
Yeah, that'd be right.
Although the price that UK price is including our VAT sales tax, so you have got the 20% tax included. But yeah, I mean, you know, the P900, P1000, yes, it's good for zooming right in and making videos, but it's not a wonderful sensor.
Yeah.
The sensor is about the same size as the sensor in your mobile phone.
Oh, okay.
Yeah, maybe just a fraction larger. You know, it's sort of 5 or 6 millimeters by sort of 3 or 4. So it's very small and very high density.
Okay then. I think we'll end up leaving it at that. So we'll say good night to all the people that are in the side chat, and thank you everyone on the panel for joining in and sharing all this exciting entertainment we've had to endure. And we'll see you all on Wednesday evening. And it's good night from him.
Good night, everybody, except for Carl.
Good night, everyone.
Except for Carl.
Good night.
Good night.